Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
When magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day. Then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
VKW. Energie für Generationen.
Hello, welcome to the WeAreDevelopers Live Week number 3, and today it's the third day. It's Wednesday for those of you who don't have a calendar. Doesn't matter, it's quality day. So it would be cool if you now start to try to solve the puzzle of day 2 of the Advent of Code, or even stop reading the PW Advent calendar about the progressive web apps. You didn't know these two, so you can check them out later on. And maybe also press pause on your favorite podcast, because today's program was brought to you, or is brought to you, thanks to our main partners for this week, the Vienna Business Agency and the City of Vienna. You can see them above my head. For those of you who are watching live on YouTube or Facebook, you can also go to wearedevelopers.com/live-week and also participate in the program, asking questions and also vote in our polls. So if you are on a web page, Slido is on this side of the screen. So what do we have for today? We have a lot of stuff, of course, also on the quality front. And we will start soon with something I always find very exciting. One-click automation. I need to drink more coffee, obviously. Just make sure to be also on this stream when we take our virtual tour for the Albertina in Vienna to give this kind of a touristy vibe, while still staying at the safety of our flats, sofas, office chairs, in times like these. And I'm not talking about the outside temperature, but you know that. If you're watching from somewhere which is not close to where I am in Vienna, it's below freezing, so it's cold. Of course, this event follows the code of conduct of all our events, and there are, like I always used to say, two versions of this code of conduct. One is behave and treat each other with respect, and the other version of this code of conduct is here. So, here we are back with Christoph. Hi, Christoph.
Hi.
Hi. So, Christoph, for all of you who do not know him yet, is IT architect and a technical product owner at Kapsch Businesscom. And he will show us now something about one-click customer deployments with built-in quality and security. I'm curious. So I will mute my camera and microphone and we'll come back for the Q&A. Christoph, the show floor is yours.
Okay, hi. Many thanks for joining. So my name is Christoph Ruckenthaler, working at Kapsch Businesscom in Vienna as an IT architect. So today I'm going to present you our road to DevOps and CI/CD. Well, for the first of all, I would just lay down the structure and the problem solution. So the project I'm going to present with our approach is together with our colleague from Kapsch CDC. Well, actually, Kapsch CDC, they are helping companies to keep bad guys out of their IT and OT infrastructure. Meaning, starting from NSM, so network security, endpoint detection, but also OT monitoring and threat intelligence. So for them, what you see here right now, together with them, we are developing different applications and tools to try to solve their needs and also providing the customers some kind of portal so they have a big picture on what's going on in their infrastructure. Well, what you can see here, we already have 3 applications, 3 features out there. So with the 3 screenshots, NSM is currently work in progress. Threat intelligence is on the agenda and on our roadmap. But now let's focus more on the technical perspective. So how the CDC and the customer infrastructure are connected and how is it working? Well, actually for each customer, you will see here a dedicated CDC zone is deployed and maintained. For there, we are using different kind of technologies and services, starting from FireEye for endpoint detection and response, Clarity in the area of OT security, and any other security IDS or IPS appliances directly deployed in customer premises. For log management, of course, we are using Splunk. So besides these tools, there are also custom-made and deployed applications. Well, first of all, automation suite, which is just interfacing with these tools and connecting to the data, analyzing it partly on defined patterns, but also heuristics and doing data analytics. Based on that, alerts and aggregated and enriched information is stored and in the first way provided to the customer. So the customer has a shared overview, so a shared picture of the infrastructure. So what's going on? Are there any problems? And also maintaining some kind of self-service character. On the other side, there's a central CDC environment where we have security incidents response tools, analytics sandboxes, as well as monitoring and log aggregation. Meaning the customer and the CDC environment is in a connected, highly secure environment using VPN, so the spanning up dedicated virtual network with the different artifacts and the different boxes, for example, that one. Meaning in that scenario, if you want to roll out new applications or just upgrading it, meaning we have to log in to the jump host as is a highly secured environment, also copying the Docker images or applications in the CDC Docker registry, and then just connecting to these boxes manually, updating the configuration, also updating the Docker tags in the Docker Compose files, restarting the applications, manually checking if the application is up and running, and from time to time also checking what's going on, how's the status from different services. Well, if you're just dealing with one or two customers, I don't think it's a big issue to do it manually. So you don't have to deal with so many different configurations and you just can do it by hand. So that's not a problem. But however, if you're going to scale that thing, it looks differently, right? So when you are dealing with 10, 50, or 100 customers, you probably don't have the time to just go to the jump host and logging into hundreds of different boxes, checking the status, doing configuration updates. Also, it's quite error prone as might have different customers have different configurations and settings. So better not touch it and try to automate that stuff. So that is a focus of today's presentation and talk, and I hope you enjoy it as well. Good. So starting from the end-to-end perspective, I would just like to highlight how we are working right now. Well, as in most of the agile companies which are doing agile development, it all starts with the user stories, tasks, and bugs, which are listed in the backlog, which are sorted by their prioritization, and they are also assigned to different releases. So I don't think that that's a big deal, and most of you are already aware of that. The next thing you might also know, so you have the different items, you then split it down to actionable technical subtasks, and all assigning test cases to them. So actually test cases, how you can test and verify the functionality of these stories or tasks. The next one, so there we are starting the implementation, meaning designing, developing, and also testing the feature. Well, as we started in that project, we've been using biweekly sprints, but however, now in the summer, we switched from Scrum to Kanban. First of all, to avoid lots of ceremonies we actually don't need, and also in that context for rolling out every month and doing operation stuff together with our ops guys, the Kanban setting was quite more efficient. Also, what we are doing, what you can see here, we are doing nightly end-to-end tests. But actually, no worries, we don't have any night shifts for testers or QA persons. And of course, the last thing, how we can get that thing out in the wild. So meaning if we are building monthly releases, pushing the Docker image to JFrog as Artifactory, how do we get it actually to the different customer promises, and that not in a manual and error-prone way, but fully automated. So I'm going to skip the backlog as I don't think that's so fancy, and just starting how we organize our work in the different settings. Well, everything starts with a user story you probably already know. So for that, we are using Jira as task management. And there we have the usual stuff like short description, what is going on, but also acceptance criteria, where you can check regarding the test cases and test scenarios if these user stories are covered or not. And there you already see that there's an additional section called test coverage with the assigned test cases. So if the user story is dealing with front-end and back-end changes, we usually create the first subtask to check the OpenAPI specification. So either it's okay or the first subtask will be enhancing or changing the API spec. Then the other subtasks are also dealing with technical tasks like implementing and so on. Additionally to that, we are implementing and designing different kind of tests to the user story. So in the first scenario, we have service tests. So there we are checking end-to-end functionality from the API perspective. And when it comes to UI, we have another point where we are going to check the GUI test cases. So as you can see here, we are using X-Ray for test management. So X-Ray it's actually just a plugin for Jira. And the good thing for that is that every X-ray item is just an ordinary Jira item, but with a dedicated type. So in that case, you can see that's test case type. Also, some interesting point is that all of our test cases are automated, meaning we selected Cucumber, the Gherkin syntax for automation. So what you can see here is an example of a service test. For running and executing that, we are using the framework Karate, which is an open source framework, and it's quite powerful. So actually in that area and also in the Cypress area, we are using PDD frameworks with Cucumber to execute these scenarios. Also, the second one, writing UI test cases, there we're also using Cucumber. Actually, in our case, as we are implementing in Angola, we are using Cypress with the Cucumber preprocessor. But you can also see here that we have a predefined test automation syntax, which we then use later on to automation. So from there, what have we learned by introducing these kind of tools and these kind of processes? Well, first of all, when evaluating tools, you will see that some tools already have dedicated workflows, and then you still have to decide, okay, shall I change my internal processes or my team to just fit the workflows? And also in the thing, you should keep in mind that you should reduce the number of tools and different languages your team needs to use. So better stick to already good integrated systems or leveraging some plugins of your existing tool chains. Also, another thing we've seen that if you're going to evaluate different kind of tools, you should not just focus on one phase of the whole development process, but keep the end-to-end process in mind. So probably the tool you're introducing in the design phase, you might also need later on in the implementation or even in the rollout phase. And last but not least, lesson learned from our side that it totally makes sense to discuss, define, and document the test automation syntax before. So even before you're going to roll it out in production, so in your CI/CD environments, better take a look first so that the automation syntax is usable, also maintainability and resilience when it comes to different frameworks. So from our side, what we've learned as dealing with Angular material, that material is trying to manipulate the structure with the magic inside, and it's going to be hard if you have different kind of technologies and technology libraries in the front end, but trying to use a common set of test automation syntax, keywords, and procedures. So there, in the best case, think about kind of abstraction layer where the QA people and testers still can use their common syntax for writing their test cases, and they don't have to distinguish between, is it the Angular material design, is it the Ionic, is it just a good. Now let's go on as well, testing the features. So I think one of the biggest changes we made is from code first to contract first. Meaning in that situation, we don't start writing the APIs in Java, but we are going to write the contract in OpenAPI. So actually, and that's a successor of Swagger Hub, where you are defining the endpoints in a specification in a YAML file, and also agree between front end and back end how the data or the objects are shared between and which endpoints do you need. For that, we evaluated different kind of tools, also Swagger Hub and so on. But then we came up that we want to have that specification also in our Git repositories. So actually, right now, we are implementing or adapting and documenting our API in our favorite IDEs, meaning either IntelliJ or VS Code. The good thing there is that all major IDEs are already providing quite reasonable and good OpenAPI and Swagger editors and validators. So it's not a big problem to go that way. But however, if you have just the specification in the Git repo, it's a good thing, but how do you want to use it in front end, in back end, or perhaps also in testing? So what we've been implementing a GitLab pipeline. So actually one step, which is just taking up the changes in the specification and publishing it to a central Swagger Hub repository. Means from now on, all the specifications and specification changes are either versioned in GitLab, in Git, and also pushed to the Swagger Hub. The nice thing there is that from there we can generate the API stubs of the Spring Boot backend just using the Swagger Hub Maven plugin, or you also can use the generation for API stubs in your Angular front ends we are currently using right now. And the really great thing is that Swagger Hub is also providing an integrated mock API server. So meaning if you're done with the front-end changes, you don't have to wait for back-end functionality to integrate and test. So from easy layouting, workflow, and validation stuff, you can also just integrate the Swagger Hub mock API server, and there you can just spin up the front end, test it, and later on, if the backend is also done, you can integrate it then smoothly. So now let's dive deeper into the CI/CD process. So what you can see here is an example GitLab CI YAML we are using in our projects. First of all, as you can see, there's not that much logic in there. So why isn't? So most of the job templates we are sharing between the projects, and we are just including these templates in each project. Meaning the projects don't, the different people in the project don't have to deal with the complexity and the magic of these steps, but just use it and extend it as templates. They are starting from build also to analyze the different sections, from publishing and also deploying the artifacts and run end-to-end tests. Here, what you can see, first of all, we are just extending one of our templates. Also, we are specifying the X-ray test plan, which means if we are running the end-to-end test, that test plan is, first of all, containing all the tests we want to run, and later on, it will also contain the status of the test runs. Also, we are specifying with environment test the environment where we want to deploy and also run the tests. And last but not least, if all the steps are done, we are just releasing the Docker image and promoting it to different Docker registries. And this is how it looks in action. So first of all, we are starting with build and test. So building artifact, running unit and integration tests. Then we are dealing with the SCA, so quality and security scans. First of all, in the quality area, we are using code climate. Next, the mutation testing. So tools we are using is PyTest or Striker. The next one in the security area is container scan using Trivy, analyze dependencies, and also for integrated code quality checks and security and vulnerability scanning of our source code, we are using Q1. And last but not least, is that's done, we are going to build the Docker image and push it to JFrog registry. If that's done, so the pipeline that succeeded, we are going to deploy these artifacts, so these Docker containers, to the test environment. If that's done, to the QA, release it, and so on. So going down to the end-to-end tests and the deployments. There we are using also GitLab for that. So actually what we do, we are scheduling pipelines which are running nightly and just taking the usual latest commits from the master branch, building the artifacts again, running the vulnerability scans, and then deploy it to Azure. For that, we are just using the Docker image and then copying to Azure and running it there. We will see later how it works. There, in the first scenario, so in the first environment, in the test environment, we just mark the third-party interfaces, but there also for test data management, we are using test data in liquid-based configurations and spinning up in-memory and database, in our case, H2. Meaning when we are going to QA, we are interfacing with the actual test third-party systems, and they are using also Postgres deployed in Azure. If that's done, we are kicking off the different kind of services, starting with the end-to-end service test, meaning for that, the Karat image will just fetch from the specified test plan all the service tests which are listed there, running then against the test environment, so against the deployed artifacts in Azure, and consolidating the feedback, so how many tests passed, how many tests failed, how many are skipped, and also the same thing in the UI tests. So also executing the Cypress tests against our own test environment, and for each failed test case there, we are just storing the screenshots. Going then in the next direction based on this information, so actually in unit test results, we are updating the test plan in X-ray. Meaning for that, every morning we have an updated list of failed tests and best tests. And also the great thing here is that you can maintain also the traceability. So there you have a test case, which is already linked to the story. And later on, we will also see that we are also linking each commit to the different stories or tasks. So actually, you can have a relation, okay, the commits are relating to these user stories and these tests are on testing that one. So in fact, if you can see, for example, here, if one's test is failing, you instantly know, okay, which feature is affected, and also are there any commits lately. Good, now let's deep dive in the deployment. So as you can also see here, there we are also starting with a template, just referencing our deployment framework. Well, the deployment framework, in our case, it's just a Docker container with some scripts, default configurations, and also some adapted ancillary roles. So meaning it's the basis for setting up and manipulating, but also deploying artifacts to Azure. As you can see here, there's also a defined Ansible playbook in there, which is just taking the information from the pipeline, also calculating and aggregating based on defined variables like the GitLab group or the GitLab repo name, and they are creating the test and QA environments in Azure. Meaning, if you are not happy with the different values and you say, okay, well, still conventional configuration is fine, but in our scenario, as you can see here, I have a Spring Boot application. So first of all, the web app port, it's not 80, it's 88. And also the health endpoint for checking if the application is up and running, it's actuator health, so the Spring Actuator framework. Also, if you need, you can also integrate other settings like here, allowing some IP ranges if you need access to other services as well. And if that's kicked off, you will see that flow in the dedicated stage. So meaning the playbook Docker image to Azure Web App is run. It's creating a resource group if needed, also setting up the Azure Container Registry, creating the Azure Web App Service, then copying the internal Docker image from JFrog to the ACR, then running it and waiting until the endpoint is available. So meaning in that scenario, we're just using this kind of information and checking if we are getting some response to them, which is not 500 for and so on. And if there's a problem, we are sending information to a dedicated Teams channel. But in that scenario, you see in the flow was executed successfully. So in that case, we are just skipping the notifications. And that's actually the result. So you can see here, for each project, we are creating a dedicated resource group in Azure with different kind of resources, starting from ACR, database, ASP, but also for each service or for each artifact, we are using a dedicated app service. What you can also see that the convention we have for the server, so actually it's the backend, and the UI, it's the front end. That information, it's just getting from the different repos. And here you can see QA and test. So this information shows you, first of all, that these different artifacts are belonging to the test environment and the QA environment. So based on that, you also see which application services or app services are belonging to which environment. Good. Well, you've seen that there in the pipeline, there are several steps. First of all, also checking code quality, checking security, but also running several tests. So means for developers and the development teams, they might have more things to do. So first of all, you have to check the reports, you have to fix the problems, and still also guideline-wise, you have to check the code quality, the styling guidelines, and so on. For that, we also switched our way we are working, meaning from the previous workflow, now we adapted trunk-based development with short-lived feature branches, meaning we don't have that complex merge requests anymore. And also to ease developers' life, we also introduced a bot, which is checking just the boring code and style things. As you can see here from a screenshot, so right now for each merge request, the bot is just checking the changed files or added files and is scanning for actually comments of to do or fix me. And also if you're committing code to the production branch, but don't fix or change any test, it's quite suspicious. So meaning if you're doing just a refactoring, it's totally okay. But usually when you're implementing features, meaning new production code, you might also need some tests or at least change the tests. Also here, as I said before, for maintaining traceability between user story, testing, but also on the code, we agreed that every commit is containing a Jira issue key, meaning the GitLab and the Jira are connected, and there you can have the traceability, so what's going on also for each ticket. And of course, the usual Git best practices also checked, like maximum of 50 characters if you're going to a one-liner. The next thing, as there are several steps, which checking the code quality and security principles. Well, first of all, it's good if you have it in the pipeline, but otherwise, if nobody cares, it's not worth to do that. So there to circumvent that problem, we introduced a stop and fix approach, meaning if one of the thresholds are violated or exceeded a defined number, the pipeline will fail. So you can see here, for example, the analyze Q1 step was failing, meaning the whole pipeline is failing. Also, you cannot publish the Docker images to JFrog anymore. Also, that's not only in the master branch, we also have it in the different merge requests. So actually from the beginning, it's going to be failing fast and you have to stop and fix the problem before you can actually merge it to the master. And another thing we've learned and that it makes totally sense to externalize shared libraries, but also components. So for example, as we are dealing with several artifacts in the Spring Boot world, it makes sense to build a base image with all the configuration stuff in there. So switching from root user to dedicated Java user, also fixing some configuration settings and providing these images as base image to the different development teams. Meaning from their side, they actually don't have to care about the basic security stuff. The only thing they have to do is ensuring that the configuration and the Spring Boot application is copied there, built and published. Also on the thing, if you have to fix security vulnerabilities like the lib2 type vulnerability lately, you just have to fix it in one project, and then it's removed also in all other projects. So lessons learned from that side. So about our journey and some pitfalls. First of all, don't try to integrate all the tools and roll it out with a big bang. So first of all, start small, evaluate the tools, try it out. Do they work or not? And if they work, go to define some kind of thresholds, but then set it to soft limits. So what does soft limits mean? If you're going to set it in production and all the pipelines are going to fail from today to tomorrow, you probably have a big problem. So in our scenario, we set these steps failing, but override the status. So meaning the pipeline is still running and could be succeeded, but they're still just as the sign that some steps have been failing. So meaning developers will see, okay, if the soft limit is switched to the hard limit, we have a problem, and then go back, try to fix to have all steps green and not just some yellow. So that's the first step, and then just decide on which date where you can switch the soft limits to the hard limits, and after that date, the entry pipeline will fail. Also, if you're evaluating and trying to integrate your own tools in the workflow, just don't assume that tool documentation will always reflect reality. So we've seen in several tools that the tutorials, documentation, but also other integration steps quite good, but not really working as it's expected. And also, if you're dealing with your CAI, CD environment, prepare for lengthy debugging sessions, and in worst case, just trial and error, especially when it comes to GitLab runners and their own configurations. Also, the thing I have already mentioned, probably try to find the IDE first approach. So meaning that the developers are able to access the reports, but also configurations and all other stuff in their IDEs. So they don't have to switch between different kind of tools. As if you're going to introduce shared, but still standalone tools, these tools are also on these reports tend to get forgotten. So actually, it's good you're calculating the report, but actually nobody cares. Good. So finally, we've built different images. We're going to ship the software to the different customer premises. So just shortly reflect the deployment procedure we have at scale. We already know the central CDC environment with the jump host and the Docker registry, and also the different customer sites with the dedicated CDC zone connected within VPN. So there, from the process workflow, we also have our dedicated CI/CD environment with tools like GitLab for CI/CD and also JFrog for container registry. There are all the code and configuration is stored in GitLab, and build artifacts and Docker images are stored in JFrog. So then when we are going to release the image, we are going to release it in JFrog, but afterwards copying it also to the CDC Docker registry with a special GitLab runner. So meaning that stage, we have the release image, first of all, in our own JFrog, but also within the CDC environment. So from the next step, what we have here, the jump host, meaning connecting to the jump host, dispatching some updates from the automation repo, and then just setting up the different steps if needed, and run the automated deployment scripts, meaning these scripts as well implemented and documented in Ansible. And what they are just doing in the inventory, we have a list of all hosts of the different customers, and in there the different Ansible tasks are just connecting to these boxes using SSH, changing the configuration, updating configuration entries, and also setting the new tag versions in Docker Compose, and restarting the containers if needed, checking if the application is up and running. So meaning if you're going to scale from 20 to 50 to 60, actually for us, it's just one-liner. We just have to kick off that playbook, and all the magic and effort of doing the configuration changes based on the customer infrastructure, but also rolling out the new versions and referencing the new Ansible tags are just done in these different kind of scripts. So how does it look, the automated deployment in action? Here you can see different screenshots. How it look like? Well, first of all, for copying from the internal JFrog to the Docker registry, we are going to use Scopio, and they are just copying the image from one location to another. For maintaining the settings per client and per host with the dedicated credentials and so on, we are using Ansible inventories, and these inventories are encrypted with Ansible Vault. So meaning we have all the information about the customer, also which configuration do they use, and other settings in one Ansible inventory file. We can use it just in the place. And the last step, you will see a screenshot of how it's going to be rolled out. In that case, we just rolled it out to a subset of customers, in that case, 2 of them. So first of all, it's just checking if the configuration is up and running. Also, if you have to change the Docker images, and if you have to change the Docker images, we are going to restart the containers. Meaning we can execute that script many times, but if the script doesn't have to change any configuration, doesn't have to change the tag, actually the container is not restarted. So it's in a idempotent setting, meaning if one step fails, you can execute it, replay it over and over again, which doesn't have any impact on that. And in case if the container is restarted, we are also waiting and checking if the application is up and running. If that's up and running, that step will succeed. Otherwise, it will fail. And there you will have then a list of the different hosts and the different steps, which shows you on which host, which step, which task failed. Good. Lessons learned in that direction. So from our side, what we've seen, better start with the mindset that it might be get automated in future, also when you start your own project. So if you have to select the format where you place your own documentation, better not go to plain text like Confluence or even worse, Word or something like that. So try to stick to a machine readable and also structured format you can then automate later. Also, when you are going with Ansible and working with Ansible, also check the use case upfront. So meaning in our scenario, we had the requirement that not all versions should be rolled out every time to every customers, but there we also have to provide a subset. So for that, we've been using different inventory host groups, meaning splitting the clients in each group. So there we can use the flag limit also to select this subset. And then again, if you want to run not all tasks in your playbook, but just some of them, like checking the status or checking the health, there Ansible tags are quite handy for that. And of course, just think about the whole DevOps practices and best practices. So even before you start designing or implementing your features, think about the testability, also automation stuff, and operation perspective. Good. So I'm actually nearly done. I just want to show you what's next. So actually what's on our agenda and what we are planning. In terms of automation and security checks, we want to finish the evaluation and integration of a dynamic security scanning tool, meaning our favorite right now is SAP, also in combination with our Cucumber tests. Also, we are planning and evaluating different tools for performance and resilience tests directly integrated in the pipelines. So right now, some representatives would be JMeter, Gatling, or Chaos Monkey to do that thing for us. And on the technical as well as organizational area, we want to go heading to from DevOps to DevSecOps. So meaning introducing also more security features like Docker content trust mechanisms. So signing Docker images before we are shipping, and also evaluating different configuration management tools and libraries where we can securely store sensitive information like credentials, but also access points and so on. So for there, we are evaluating Git Secret, Ansible Vault. Perhaps it's going to be a combination of these two. Good, thank you very much. You enjoyed my presentation and you're still here, of course. So if you have any input, feedback, or questions, feel free to ask. Or just write me email or any other channel like LinkedIn and so on.
So, thank you, Christoph. Very insightful and so full of information. My head is still bzzzt. Yeah.
Sorry about that.
Yeah. No, that's good. That's good. That's very good. You gave me some new things to think about, and that's always, this is why I am watching this. So I cannot
Perfect.
talk for the audience, but can you stop your screen sharing?
Sure.
And then we can go through questions. We got a lot of questions from the audience. For instance, Fabian wants to know, how is your experience with using Cucumber to generate test cases? How well does it work for non-trivial test cases?
Okay, well, actually, that's a really good question regarding that. So meaning we've been also evaluating if we can generate our test cases and how we can integrate it. But from our perspective, as said, first of all, we had to introduce kind of abstraction layer. So meaning if we want to test the whole table, it's quite painful if you go with Cypress and so on. So there we introduced some kind of test automation framework, just using a simple Cucumber syntax, meaning, okay, and that table has to contain just with some attributes, and then just using the magic in Cypress to get that information and validate it.
And then a question which fits quite good, which is the next highest voted one from Anonymous. That's, by the way, the person who asks most the question at this event. How do you deal with test data? Is there a generator in place, or do you obfuscate production data? Do you have predefined test data database containers in place?
Yep. Actually, we are going from test data in two different ways. First of all, in the test environment, we are using static test data. We are having in the liquid base. So meaning actually in the liquid base configuration, we have a CSV Excel file, which is containing static test data. For that, we have to ensure, first of all, that we are just using a in-memory database when we are deploying the server. And then when we are executing the test cases, so cucumber tests, that we can really check if this user is assigned to that case, for example. And that's the first thing. And on QA, we are using, so we don't use production data, as here in the setting of CapCDC, we're quite in a sensitive area we probably can't use. So there we are just dealing with regular test data. We are setting up scripts or deploy directly in the database or third-party systems.
So, and then we have some questions from Steffen. And he wants to know why Cypress instead of Selenium or Playwright? Was it on the wish list of the front-end developers? Are those tests only written by the front-end developers? So it's a lot of questions.
Okay. Yeah, regarding that one, yes, it was also on the wish list of the front-end developers, but why did we select it? So the main applications we are writing are SPAs, meaning for that, we also tried out Selenium and other stuff, but it didn't work that quite well in that area. So that's why we selected Cypress. And who's writing the tests? Well, the developers, so in the case, the front-end developers are writing the unit tests using Jest and writing integration tests using Cypress. The service tests or the UI tests are usually writing the QAs, but could also be that the developers, so front-ender or back-ender, would write them.
And more Steffen questions. It's Steffen, not Stefan, so don't throw things at me. How is the UX? Oh, wait, no. How do you handle explorative testing? Is it done by the PO or is there a dedicated tester? Or do you?
It's actually done by the PO. Well, in the project, it's done by the PO. Well, in our case, TPO. So I'm doing it, but also testers are doing it. And in the project, also CDC is doing UAT or explorative testing.
And do you?
Mainly me.
And that's a Stefan question. And do you also put in the pull in the customer or somebody from the business unit?
Yep. Well, actually, not really the customers. From the business unit, CapCDC are the experts in that domain. So these are the security analysts, not the technical programmers. So they are providing us with insights about the workflow, also the functional aspects, and also evaluating the processes, how it should be.
Thank you. So, Steffen.
Steffen again.
Steffen again. How is the UX UI taken care of? Is UX UI part of the dev team, or do you have some designers around doing the scribbles, etc.? So, etc.
Okay, that's a really good question. So the really good answer is it depends. So depending on the skills of the front ender. So, okay, first of all, we don't have dedicated UX designers or just designers, but some of our front enders are quite good in UX and design these applications and going who's setting up or designing mockups and so on. Also, it's depending on the setting for that project. For example, I was doing most of the mockups, but also together with a front end, just checking if that's okay, if it's going the right direction.
Then we have Candida. What about JUnit in Spring Boot backend? Is it factable or not to test in your case? Thanks for your talk.
Okay, yeah. So besides the Karate and the Cypress, we're also using classical unit component tests and integration tests. So in Spring Boot, classical JUnit or Mockito, and also Rest Assured for checking the functionality. But then here we are just using the BDD frameworks to abstract the technical Java or on TypeScript, JavaScript perspective more in a user focus or end user focused perspective. Why we are doing that? Because X-Ray, for example, also allows us to generate reports. So we can just export all these test cases and present it a client. And even the more technical clients can follow the syntax and see the different test cases and scenarios, and also have an overview what was tested and was not, and how it was tested.
Mm-hmm. So we are nearly running out of time. We still have questions. Let me pull one from the bottom of the list, which I think is very interesting. So it's very objective. How do you ensure that documentation is kept up to date? Question from Fabian.
It's a really, really good question. So, well, the thing is, usually documentation is not up to date. So that's why we switched also from Confluence or some Word documents more in the structured and automation way, meaning if not all properties are correctly set, for example, in the Ansible inventory, and not documented properly how it's working, just the cases will fail. Also, we have the same with the contract. So other teams in the past started to document the REST endpoints, also in Confluence with the request and responses, and usually this documentation will never get updated. So as I said before, if you have to deal with that challenge, try to find the automatable way and also some structured formats you can also check and validate, perhaps with some steps in your pipeline.
So, thank you. Can I have? No, okay. So the production is telling me I have to cut it now. There are still a lot of interesting questions. I suggest I forward them to Christoph, and we will make sure that Christoph gets the possibility to put them to put the answers out on our blog. Now, since Christoph took a lot of effort into creating this presentation, and it's a very complex story, make sure to also answer the feedback in Slido right now. And this is where I say thank you, Christoph.
Thank you.
It was amazing talk. Hope to have you again to learn more about the journey you took. And
definitely,
because I think this is a journey where there is never an end. It's always you're learning and then you're changing and learning and changing.
Totally, yeah.
Yeah. So we will see him again. And we will be back after a short break with Evelyn. Bye, Christoph.
Thank you.
Bye, audience.
Bye-bye.
When magnetic fields move and electrons start flowing. When you feel that anything is possible, when the night can turn into day, then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
So, and now we are back with Evelyn. Hi, Evelyn.
Hello.
So, you will tell us how AI will change the future of software testing. And I give all of you out there a hint. When I first heard what this talk is about, I thought there will be a lot of happy people out there. So, I will now shut off my camera and my microphone. And Evelyn, the stage is all yours. Thank you.
Thank you. So thanks for the very nice introduction. And thank you also for the chance to talk here today at the WeAreDevelopers Live Week. In today's talk, you will hear all about software testing and how modern technologies such as artificial intelligence will change this field of software engineering. But let's start with a short overview of the contents of this topic. At first, you'll hear an introduction to software testing, so which problems are solved by software testing, how did it evolve over the last couple of decades, and how could it look like in the future. Then we'll proceed by taking a closer look at AI-powered software testing. In particular, we will learn about symbolic execution, which is a technique to fully automatically generate test candidates. and then I'll give you a very short demonstration of the Sunflower product that can be used for autonomous unit testing. And like the other sessions, we will also have QA block at the end where you can ask all your questions or maybe give me feedback to the talk, which I would appreciate very much. So software has bugs. We all know that too well because we are simply not immune to mistakes. If you write more than a simple Hello World program and you exceed probably a couple of 100 lines of source code, chances are pretty good that you introduced a bug somewhere or maybe even a couple of them. And if you think otherwise, you probably haven't looked close enough yet. And the only option we have to reveal such problems is through very thorough software testing, which brings us to the next problem. Humans are not very good at software testing. We work imprecise, we overlook mistakes, and we usually get tired at some point. But we still rely on software testing because we now know that it costs up to 200 times more to fix a bug in production than if we already fixed it right during development. So that's why we typically spend more than 30% of development time on software testing. And yet the annual damage we face due to software defects is devastating. So $1,700 billion, 1,700 billion. That number is so high that we cannot even grasp it anymore. So to put it in some perspective, all the buildings in New York City and you would have still 400 billions left. And you may now think, yeah, well, those damages surely come from projects that are not properly tested. But that's simply not true. You have here two striking examples on the slide. One, the crash of an Ariane 5 rocket ship from space traveling, and the Heartbleed bug from the encryption domain. In both industries, engineers test and verify extensively because bugs can have such devastating results. And that's the reason why freedom from errors has one of the highest, or maybe even the highest priority. And still, those bugs were overlooked. And apart from these monetary losses, we should, of course, not forget about those problems that actually harmed people. So that brings us back to the things we can do to avoid such mistakes or to at least decrease their likelihood, and that is software testing. So every software project is tested somehow. If you follow the traditional approach, you do manual testing. That means you try out your software by hand. If you follow the textbook definition of manual testing, you usually have a test manager who defines test scripts. These test scripts are nothing else than a step-by-step guide that the manual tester works through and checks for each of those steps whether the observed behavior is what the test described or not. So basically, for this kind of testing, we have two areas that eat up time. First of all, we need to define our tests. That usually happens once. And we have to do those manual test runs. And these test runs have to be performed before every release of the software. And the more complex your project gets, the more tests are required to properly check whether your system is supposed to what it is supposed to do. And so you can very well end up with several tens of thousands or maybe a couple 100,000 test cases. That means that a single test run can take up to several months. And that clearly stands in the way of modern software development, because our goal is no longer to release yearly or quarterly new versions of our software. With continuous delivery, our goal is to bring new versions of our systems to our customers on a daily basis, ideally several times per day. And we simply cannot do that with a manual testing approach. So let's take a look at the first evolutionary step, which is automated testing. Here, we no longer try our programs out by hand, but we rather automate our test cases once and are then able to run them in an automated fashion over and over without any additional effort. But also for this testing type, you have two areas that mean effort for you. The first one is that you still need to define the test cases. And the second one is that you need to do the automation. And this automation step is very cost intensive. So it usually takes several times more to automate the test case than to run it manually. But on the bright side, you can execute them as often as you want to. Apart from this initial effort, you have regular maintenance work to do. So if you change your product, you also have to update the associated tests. So let's quickly compare those two approaches. This graph shows clearly that manual testing is much more time intensive than automated testing, because it requires a steady effort. The automated testing, on the other hand, has this high initial investment and afterwards the maintenance work. And due to this initial costs, you have to do several test runs before the automation step pays off. And that is the main reason why we often make the wrong long-term decisions. We are in a stressful phase of our project. We want to get the next release out as fast as possible. And that's why we postpone the automation step. But on the long run, that's clearly the wrong decision, because automated testing, it requires much less effort. What we haven't mentioned yet is that both of those two approaches cannot in any way guarantee freedom from errors, because they heavily rely on us, that we do our work error-free, and that's simply not possible. So it's crucial to find the correct test cases and all relevant ones. So even if you find your 1,000 test cases and you automate them, if you're missing a single critical case, your system will still crash, even though you automated the first ones. And on top of that, as I already mentioned, we work imprecise, we get tired, we overlook mistakes. And on top of all that, a person cannot find a certain kind of error if he or she has never heard about it. So if a software tester does not know that the SQL injection vulnerability exists, then he or she can simply not check your system if it's in there or not. And of course, there are products out there, but the main issue with them is that they bring only small increases in productivity. So testing is still time and cost intense. You need them, and most of them bring hardly any process improvements. So they make the tester more efficient, but not more effective. And Thorsten Dirks, CEO from Telefonica Germany, put it quite well, what it means to automate processes or to digitize processes without ever questioning the process itself. And I always think that quote is quite thought-provoking. That's why I wanted to share it with you at this point. So to sum up, or not to sum up, yeah, to sum up, we first looked at manual software testing, which stands in the way of today's modern software development, because we simply cannot keep up software testing at the speed that is required by development. Then we saw the first evolutionary step in software testing, which is automated testing. It gets rid of these manual test runs, but it has high initial effort and it has maintenance effort required. Both approaches cannot guarantee freedom from errors. And the really interesting question now is, how could the future look like? So how could the next leap in software testing be? How will we test in the future? And here I have another quote, this time from our CTO, Markus Zimmermann. The fastest task a person can do is one that he doesn't even have to do. So it can be safely assumed that in the future, we will be able to automate the complete software quality assurance process and hand it over to an artificial intelligence. So what does that mean? It means that not only the test case execution is automated, but also this part of finding all relevant test cases is automated. So this incredibly hard step to decide what and how to test will be done by an artificial intelligence. And that brings many advantages. First of all, we will test much more accurate because machines can work 24/7 without getting tired. It will be cheaper because up to now, still the personnel costs are the biggest chunk in any software project. And we will be much quicker in software testing because you can let as many machines work in parallel as you want to. All right, but what does that mean for our daily development tasks? The cool thing is that we will never have to do those boring, repetitive tasks again. So these will be given over to machines, and programming should become much more or even more fun as it is right now. Bugs won't be overlooked anymore because machines work effectively all the time, and errors can be corrected at an early stage. So they are found directly in development and not months later somewhere in production. That means that you can still remember what you thought when you wrote a certain piece of code, and you do not have to figure out months later what your original thought process was. So debugging becomes immensely easier than it is oftentimes right now. All in all, software will be developed much faster because testing is done by machines and because debugging is streamlined as you get rapid feedback on your code. So how long will it be before artificial intelligence can really test software without humans the way I described so far? And the cool answer to that question is that for a certain part of software testing, it is already possible today, which is the part of writing automated unit tests. And before I start talking about unit tests, I would like to shortly recap the automated testing pyramid. It's basically a best practice that tells you how much you should test on which level of abstraction. So there are 3 different levels, which is system testing, integration testing, and unit testing. And the automated testing pyramid tells you how many tests should be on which level. A system test usually verifies that your software does what it is supposed to do. So you typically look at the complete system, at a production deployment that's typically equivalent to one that you would ship to your customers. So there is no mocking involved, but every component is like it's supposed to be. And the recommendation is to have the fewest number of tests on that level. Next, there are the integration tests. They are meant to check if two or more components work properly together. So you do not look at the complete system, just on the relevant components, and you check whether they can talk to each other or not. And you should have already more integration tests than you have system tests. On the lowest level, we have the unit tests. They are meant to verify whether a single function or method is working as expected. So ideally, you look at them in isolation, and ideally you have the majority of tests on this level. The reason for that is that we now know that up to 95% of all bugs can be reproduced or can be triggered by unit tests. So you do not need an integration or acceptance test for them. And additionally, you can write them way faster, and debugging them is also easier because you have fewer contexts to think about. You already know the involved function and you do not need to dig through the complete system. All right, yeah, what's also important here is that those testing types are complementary. So you shouldn't skip any of them, but stick to the automated testing pyramid because it gives you the best ratio of time spent in testing and the likelihood to reveal errors. So let's next take a look at unit testing in detail. As I mentioned, they are meant to verify that a function or method works correctly. Usually they are split up in 3 areas. So you have your setup code that's responsible to get the correct state for testing. So you decide on the input values, you decide on the state of the receiver, you may also look at the environment, then you call your function, and finally you validate your expected result. So once again, look at the return arguments and maybe also verify the state of the receiver. So that sounds pretty much straightforward, but you should not underestimate the effort that runs into deciding on the correct values for testing, because oftentimes it's not so easy to decide with which inputs you can reach a certain line of code. So you may look at that code and not know it yet, and especially if there are many paths and early exits, it gets very, very hard. Overall, the goal of unit testing is to specify a set of tests that verify the complete behavior of a function. So ideally, you have a single test for every aspect of your code. That means missing tests are, of course, a bad thing, but also redundant tests are a bad thing, because a redundant test means more maintenance effort as you would actually require. But let's now do a really quick example and unit test this compare function. It has 2 inputs, I and j, both are integers, and it returns an integer. This function is meant to determine whether I is smaller, equal, or larger than j. Okay, that sounds like we need 3 test cases. One where I is smaller than j, let's use 6 and 7. We expect here the return value to be -1. Then let's choose 2 equal values. Doesn't matter, let's choose 4. Here we expect the return value to be 0. And finally, we choose a test case where I is larger than j with 7 and 6, and expect the return value to be +1. So it looks like we're finished testing because we have one test case for every aspect of the specification. But sadly, specification-based testing is not enough because we oftentimes introduce errors in our code, and this way also breaches to the specification. So it's essential to also look at the implementation and check whether you can find cases that do not fit the spec. And we now see here the actual implementation of the function. We have here a subtraction and then an if-else cascade, which looks like it shows exactly the three cases we already have here. But the problem I'm getting at is this arithmetic operation, because every arithmetic operation can overflow if the computed result does not fit anymore into your chosen data type. So if we, for instance, choose the value I is 0 and j is min-inted as input variables, we would expect the return value to be +1 because I is clearly bigger than j, but we received -1. So this is an actual change in behavior and a breach of the specification. And we could not have found it without looking at the underlying source code. All right, so wouldn't it be cool to have a tool available that does exactly what we just did? It gets source code as an input, and it then determines or spits out a set of unit tests that reflect the current behavior of your function. So on the one hand, there are tests for all the non-error cases, which are the first three tests we had in our example. And it also tries to trigger errors for all operations where there could be one. So for instance, if you have an index access, it would try to trigger an index out of bounds exception if it can trigger one here. Or if you access the member of an object, it would check for null pointer exceptions. In case it can find one, it would spit out the unit test too. And there are different techniques that you could apply or that could maybe help in achieving this goal that I described here. The first one that comes to mind is boundary value analysis. You might have heard about it in one of your testing lectures. The basic idea here is to partition your inputs into different areas and then to use values at the bounds of those partitions. So for instance, think of it as taking a very small number, a medium number, and a very large one. With this technique, you do not look at the underlying source code, so it's a black box testing technique. And that's one reason why you reach very low coverages with it. So you won't have very high test coverage. The next option we would have is fuzzing. With fuzzing, the basic idea is to use random values. Fuzzing has found countless problems in computer programs, so it's a good technique to reveal errors, but it's not very well suited to generate high coverage test suits because as you use random numbers, you solely rely on luck. So you might have good results, but you also may not. So that brings us to the third technique, which is symbolic execution. This technique promises the highest test coverages because it targetedly computes the input candidates you need for testing. It's a research topic that was already established in the mid-70s but up to now it hasn't made it in any products yet because the computational power of our machines were not good enough, and also the used constraint solvers were not far enough yet. So you can think of a symbolic execution similar to a usual program. So normally the computer works on concrete inputs. So beforehand we had values 4 and 4 for I and j. But when you execute something symbolically, then you do not use concrete values, but rather symbolic ones. So you reason about all execution branches at once, and you try to trigger errors along the way. And that may sound now a bit abstract. That's why I prepared an example to symbolically execute to give you a better understanding of that technique. So on the left-hand side, we see again a very short function that gets two inputs, A and B, both are integers, and it does several computations. And our goal now is to figure out whether there can be a division by 0 in the last line. So you can go ahead and try whether you can find a solution where there actually is a division by 0 or not. And I will go ahead and show you how the symbolic execution reaches its result. So as a first step, we take a look at this first statement, which is an assignment. By the way, this is Go code. And the assignment leads to x is 1 and y is 0. We store this information in this green dashed box, and you see here x is set to 1, y is set to 0, and a and b are set to a question mark. That's because we know nothing about the two input values yet, except that they are integers. The next step is then to take a look at the if condition. And if always means a path split, so it has a true and a false branch. If we first take the false branch, that means we need to set a to 0, otherwise we would enter the loop. So that's why we update our equation system in the dashed box, where a is now set to 0. We already reached the return statement, so we can now ask the constraint solver whether it can find a solution for x minus y is 0. You can think of a constraint solver as a box that you hand over an equation system or constraint system, and it will tell you if there is a solution to that system or not. And in case there is a solution, you can ask it for one concrete example that solves the equation system. But right now it told us it's unsolvable, so we need to proceed with the true branch of our if statement. Now we set, or we reach the next assignment where we set y to 4, and we reach the next if statement. This time we constrain b further, so it doesn't have a concrete value yet, but we know for sure it can't be 0 right now. We again reach the return and go ahead and ask the constraint solver what the solution to this equation system is, but it tells us, no, I can't solve it, there is no solution. So up to now, there were no divisions by 0 possible. Let's look at the true branch again. Here we have the next assignment where we set x to 2 times a plus b. It's also not concrete yet. And we again reach the return statement. And this time the constraint solver is able to find a solution with it, which is a is 2 and b is 0. So there is actually a division by 0 possible. This example was meant to give you a rough understanding of how a symbolic execution works. So basically you follow all execution paths And for each of these paths, you carry along an equation system that is then handed over to a constraint solver. And that solver tells you which values you need to use for testing to reach that path. All right, so this example was restricted to primitive data types and 2 or 3 if statements. But rest assured, symbolic execution can also be used for more complex constraints like loops, functions, function calls, recursions, and also complex data types like strings, arrays, and classes. Of course, next to the symbolic execution, you also need a product around the symbolic execution to make it available to everyday development. And that brings us to the Sunflower product. So we built a product that is able to automatically find test candidates for unit testing based on symbolic execution. It puts these test candidates into executable unit tests, executes them, and analyzes their execution. So all the steps that are usually done by the developer are now performed by Sunflower. And that with even increased quality of your software and your tests, because it's very thorough. Sunflower relies on continuous testing, or it applies continuous testing. That means whenever you push a code change to your repository, the Sunflower product will reanalyze your repository, will adapt existing test cases and generate new ones. So there is no maintenance effort and there is never ever untested code. And it also does runtime analysis during the execution. This has the advantage that you only have true positives. So for every reported bug, you can download a unit test, execute it on your machine to reproduce the error and readily fix it. Overall, the product runs over the whole code base and determines first which functions are in your code. Then it determines the relevant paths through your function, and it computes for every path the required input and output. And those values are then put into executable unit tests. So you end up with a high path coverage test suite that reflects the current behavior of your function. So you can focus on developing instead of testing so much, and bugs will still be automatically found. And you can use the Sunflower unit tests as a safety net. So if you plan to do a refactoring, which means you do not want to change the behavior, but you just want to make your code better readable or better testable, then you can use the Sunflower unit tests to be notified about changes in behavior. And yeah, the execution has the advantage that there are no false positives. That's a typical problem from static source code analysis tools, where you first have to find out, is the reported problem a real problem or not? Next, you cannot forget to execute your tests. Because a unit test that is not executed is worthless, or not executed with every code change. Let's put it that way. And the execution allows you to reveal obvious mistakes such as program crashes or memory leaks. But I guess it's now time to take a very quick look at the product itself. For that, I will change in some test environment. You see here now the project creation page. When we built Sunflower, we set a very strong emphasis on its to make it very easy to use. So ideally, you only need to give the project a name, and you need to let us know where we can find the source code, so the Git repository URL. And that is everything that we need to start the sunflower analysis. We are now at the dashboard, which basically gives an overview, quality overview. So in the area that should be highlighted now, you see how many files are in the project, how many errors were there, how many problems did we find, and how many tests were generated. An interesting aspect of the dashboard is also that you see that we currently support 2 programming languages, which is currently Go and Java. And it also lets you know whether the generated tests passed, so if there were green in the execution, or if there were some unexpected errors that you should take a look at, or if we maybe found some failing assertions. And also the found problems are categorized after their severity. So for instance, here we have an error. Those are problems where we need your help because they actually hindered us from analyzing a file or the whole project. So if you check, for instance, something in that does not even compile, then we cannot analyze it because we can't execute it, as we also do dynamic analysis. Next, there are critical problems. These are potential security issues that you should definitely take a look at. But let's now move on to the first example, which might look familiar as we tested that one beforehand by hand or manually. And the Sunflower product also finds 4 test cases. The first one is where both values are the same. You may note here that Sunflower computed the values 0 and 0 because we always try to find values that are easy to understand for humans. And there are the 2 other examples where I and j are one smaller and one's bigger, or in that example I and b, sorry. And we have the overflow that I mentioned. So you get the inputs and the outputs, but you can also view the actual unit tests that were executed. You have the option to copy them from here or to simply download them to execute them on your machine. But they have been executed by the Sunflower product itself. And you saw beforehand that when you think or when you try to write unit tests yourself, that takes some time. So you have to read and understand the signature. You need to take a look at the body of the function. You need to figure out if you're already done with testing or not. And all these steps, so finding the inputs, the outputs, writing the unit tests, that's done with Sunflower within several milliseconds. So we are really, really fast in what we're doing. I'd like to now show you another example that highlights another aspect of Sunflower, which is this. So that function is not much longer than the compare example, but it's already more complex. So we have here an early exit, then there is a loop, and finally another if condition. And if I asked you to find the values to test this line, it may already take some time to figure out how to do that. So you have to understand all the code above. You might read the commands, which can lie, by the way. And yeah, it might take some time. And once again, Sunflower is quite fast in finding one solution to reach line 14, which is in this example 20 and 22. And apart from those values, you have once again the full coverage test suite. Another example is this is sorted function. It's supposed to tell you whether the input array A is sorted or not. And the interesting thing here is when you ask a person to look for problems here, almost anyone focuses at first at this part because it looks rather complex. So there are two index accessors, so it could be that there can be an index out of bounds, right? But the interesting thing here is that that's not the problem. There is a null pointer exception with this a.length, which, by the way, wouldn't be an exception in Go, just in Java. So that's a language speciality. And there is a logical problem in here. If we look at this second test case, we have the empty array for A, and this function tells us the array is not sorted. And that's probably not true. So you can discuss whether the specification should be here true or false. But the reason why I mentioned it is that we are typically much faster in checking finished solutions than in coming up with the solution ourselves. So if we go here through the generated tests, we are very fast in telling, yeah, they are correct, than we would be in finding out with which values we should test in the first place. The final example is this mocking example. So whenever you get input values to their interfaces, you need to decide whether you test with some actual implementation from your code base. That means you are, by definition, not necessarily unit testing, because then you have external dependencies as well, or you generate the mock for your interface. And this mock generation is also automatically performed. I'll show you the unit test for that. So the compare example returns equal, weaker, or stronger, depending which animal is stronger than the other. And to, for instance, reach this expected equal result, the associated mock for that is also fully automatically generated. And yeah, in this scenario, we use Mockito for mock generation. All right, very shortly back to the presentation. So we are very active on social media. In case you enjoyed that talk, please follow us there. Also take a look at our website. We recently started with a technical blog series, so register for our newsletter. And we are also hiring. So if you like to work on challenging algorithms, or you're interested in formal methods of software engineering, please drop us your CV or recommend us to your colleagues and friends. Recently also a front-end developer position opened up. So if you're all about front-ends and you want to make software developing easier, please join us. So that was quite a tour. We looked at the evolution of software testing and its potential future. We learned about symbolic execution and even symbolically executed a function. And in the end, you shortly saw the Simflower product. And I'm now very keen to hear your questions.
So, hello, Evelyn. Can you stop screen sharing, please?
I'm not sure how I can stop sharing because here we go. All right.
Okay. It was probably not tested very good on the user experience front. So we have some questions. One is from Steffen, who is, oh my god, who is abusing his keyboard today with all his questions. It says, it looks like pricing starts at 3,600 a month. Still, it seems to be very useful, but how to evaluate? So do you provide a test version, more or less, is the question.
We provide proof of concepts. That means we usually analyze a complete project from your side, which gives you a very good understanding of how well Simflower performs on your code base and how the generated tests looks like.
Mm-hmm. Thank you. And Peter has another question, which is, do you have a CI/CD pipeline integration?
Not yet, but that will be in soon. So we recommend to integrate Simflower in a nightly build because it's not a real-time application, so it might be a bad idea to wait for merges, but do it once a day.
Yeah. Okay. Then Anonymous wanted to know which technologies do you support. I can tell you this because I watched the presentation. It's Java and Go.
Yes.
And
very good.
And somewhere below, I also saw that somebody was interested, I think it was Steffen, about if there is something about a roadmap or upcoming languages, or if you plan also to go beyond unit tests.
We plan both. So right now we focus solely on unit testing. Because it's the easiest or the more ready step for symbolic execution. But we plan to go beyond that to also expand to UI testing, for instance. Mm-hmm. And language-wise, I guess at the end of next year, we plan to introduce the first next languages.
Mm-hmm. And so then Carlos, okay, Carlos says unit test is anti-product. If it comes from erroneous source, doesn't that generate even more erroneous unit tests? Double trouble having passed tests that are wrong. So I think he points at the false positives.
He points towards the direction if there are logical problems, you will have unit tests that reflect these problems. That's exactly what we saw in the is-sorted example. So it's oftentimes easier to check those examples than coming up with them by yourself. But if you have a unit test that triggers an index out of bounds access, that is for sure in all cases a very valuable test case because you need to fix it, otherwise your program might crash. And to the point of finding logical problems, we will also give the option to describe the intended behavior with pre and post conditions. Of course, this description needs to come from the user, but then the unit test can verify whether the intended and actual behavior fit.
Okay. And then there are two questions from Peter, which are very short. One is MCDC coverage.
Yes.
Yes.
So yes, there are different kinds of coverages. And MCDC coverage is required for certain kinds of certifications. And we compute MCDC coverage plus additional error coverages. So the standard specification of MCDC tells you which cases need to evaluate to true and false for all conditions, but it does not necessarily tell you that you need to check for all arithmetic overflows. So it's MCDC coverage, and a bit more.
Okay. And his second question is one I was also thinking of asking. I do not know if we mean the same. He says, is the software server-based? And my question would have been if you only offer this as a hosted service, or if we could also have that on premise.
I will answer both questions. It is server-based. The main reason for that is that that sometimes developer machines are not as powerful as servers, and we offer it both as a service and on-premise version. So you can choose which one you want to use, and there is also a command line interface to automate working with the product better.
Perfect. So, wow, I have so many questions left. Stefan wants to know if this is open source. This was at the beginning. This was answered because he asked. Carlos has he has feedback for a presentation. He says, words matter for future readers. Please rephrase human beings are the problem, or leave it as a provocation reminder.
Yeah, I know that one. We had some discussion about it. I will take that with me. Thank you.
So, thank you, Carlos. So then Christoph wants to say, shouldn't tests ensure that implementation is correct and verify the specification as seen in test-driven development? Else we just have a high code coverage without any benefit.
I do not agree that you have high code coverage with any benefit. So I would not recommend to let the tests be generated and never look at them, because then, as we already heard, you won't find logical problems. And I would say Sunflower is complementary to test-driven development, because test-driven development has many advantages. So you write code that's better structured and better testable, which is a good thing also for the Sunflower product. But you usually do not write tests that reflect the whole function. So you write 3 or 4 tests that display like the green scenario where everything is fine, and you often forget about corner cases that can be really important.
Okay. So I still have more questions than I have time, and at this point I wanna just put one more, and it's from Candida. Thanks a lot for your talk, Evelyn, and I can only agree. There are some questions left. I will send them over to you so that you get the chance to see the questions. And also, maybe if you want to answer some of them, we can also put that on the blog afterwards. Okay. Thank you for coming. I know you are very busy at the moment. And yeah, for the audience, I will now have to run over to Albertina with a mask and find our tour guide for the next thing we do. So we will be back after a short break. Bye bye.
Bye.
Good afternoon. Welcome to this virtual tour in the Albertina here. My name is Frida Zapp, and I'm going to give you a little bit of an view or an entry into this museum, the Albertina in Vienna. And it will happen, I will share my screen and to give you a virtual 360-degree tour in a couple of minutes time. And before that, I will show you a picture of the museum where I'm currently at as well. Just a couple of things firsthand. So I will share my screen and then I'm in this virtual tour. So I would like to ask you if you do have any question. I was asked that you can put it into Slido, I think, your chat function, and this will then be forwarded to me into Zoom. So I will take a couple of minutes at the end of the tour to answer all your questions if you have any. But please feel free to ask as many questions as you want. If it's something is unclear, if you would like to know something more about something, please do let me know as well. Yes, and so I'm just going to start to show you firsthand a picture of the Albertina. So this is the beautiful Museum of the Albertina in Vienna. It's located directly next to the State Opera. So we're pretty much standing at the State Opera at the moment and just having the view onto this like Baroque palais. And you see the museum is located in the house. And then you have this big entry with a wing, this metal wing covering the entry, designed by Hans Hollein, a very experimental architect, an Austrian architect. And you can already see like kind of the contrast as well that the Albertina houses very traditional and very historical art exhibitions from the Renaissance. Especially we had a big one again from Albrecht Dürer because we have one of the greatest masterpieces by him. And then also leading up to contemporary art. And this is what we're going to see today. We're going to visit a contemporary art exhibition that we have on display at the moment. And with that, we're going a little bit inside. So I'm actually in the building at the moment as well, but I'm going to show you, we can't really, I'll show you a little bit of an insight into it. And with that, I'm going to show you now another screen. That is this one. And here you can see pretty much the entry. The entrance is here, and you have a little bit of a view as well into the building, which is this Baroque palais that was founded by Albert von Sachsen-Teschen. This is also where the name Albertina came from Albert, who was a graphic art collector and founded the Albertina in 1776 with all his collections and graphic artworks. And now it's one of the one of the biggest graphic art collections in the world, but now also houses exhibitions leading into contemporary art and has a beautiful permanent exhibition as well from modern painting or classical painting as well. And we're going to go today into to see this exhibition, and it's called My Generation, the collection Jablonka. And the collection Jablonka is collected by Raphael Jablonka, who is a Polish-German art collector and gallerist who opened his gallery in the 18th as well in Cologne. And he was born in the beginning of the 50s, so I think 51. And he is displaying actually artists of his own generation. So artists who have been born in the 40s or 50s are still working today, but mostly the exhibition covers artworks that were actually like made around in the 80s and 90s, I would say. And so we're currently on the ground floor of the Albertina, and we're now taking the escalator down, which you would normally do if you visit as well to see the collection Jablonka downstairs. And we already come across great artworks, which are quite large as well. This one is around like 3 meters times 5 meters, so quite big in size as well. And we're starting off with a Spanish artist, Miquel Barceló. And Miquel Barceló was born and raised in Palma de Mallorca, so he's a Mallorcan artist who still currently actually works there as well, and in Naples. And he started off mainly with painting. And he used a lot of like this genre of kind of exploring the traditional genres of paintings and also of draftsmanship, and then moved on to ceramic artworks as well. And he got a commission to design or to create an artwork for the cathedral in Palma de Mallorca, which covers 300 square meters of walls in this cathedral, also windows as well, with his works, where he created these like clay, these ceramic like huge plates for. And all these plates, we have like 3 of these on show at the moment. I'll show you some other ones as well. Kind of use or like are working with the story of Jesus from the Gospels, where Jesus fed thousands of people with only 5 loaves of bread and 2 fishes. So it's the miracle of loaves and bread. And we see here as well, we could see Jesus in the middle on the left to the fishes here. I can zoom in a little bit. Yeah, but you can also say maybe that it is the artist as well. So it's kind of like it's also an autobiographical works. We see next to actually next to the human figure, we see the footprints of Miquel Barceló as well. So we do kind of have the artist present in the work as well. And the way actually Miquel Barceló is making these artworks is that he puts these giant plates of ceramics of clay into his studio and puts a camera in front. And he is standing behind the plate with a little monitor and showing kind of what's happening in the front of the plate. And then he's pushing, like he's punching the plate to kind of carve out these forms and these breads and these figures. So it's quite like a physical process as well that he approaches these artworks, and he does want to use, like you see, like the onyls and kind of and kind of traditional forms as well of these clay pots that he works with as well, and then the fish coming out. And then the bread loaves, of course, as well, because of the miracle of the loaves and the fishes. And then, yeah, the whole story coming together in these plates. And then it's burned, and this is how it becomes like a ceramic tile artwork. And then later on he actually paints on top of this. So it's kind of like also in between, like the space of painting and also of sculpture in a way as well. We do kind of, he works with these regular reliefs in a way that he became very known for. And we also see that actually these clay or these ceramics actually crack in the firing process. And that also happened with this giant artwork in the cathedral. So it was later, like actually in this cathedral, then reassembled like a giant puzzle, piece by piece, coming together to create like this astonishing work. And it was actually opened 2007. Miquel Barceló didn't attend the opening because he is himself like doesn't really believe in religion, and he doesn't feel part of it, which actually caused also a great critique in the Spanish press as well, because there was a lot of like debate going on then whether kind of whether the church or the cathedral is actually a place for like a contemporary artist to take over. But I would just like to, I can just like show you around a little bit, like the details of the work. And you do see kind of like fingerprints, footprints, and then later where he cuts like into the clay, like here with the mouth of his fish as well. So it is a very kind of, a very physical process that Michael Barcelo really involves himself in as well. And if we go back, I can show you also the other ones, which is here a little bit more colorful as well. You have a little bit more sea kind of urchins and sea animals like the eel as well, and the fish coming out. And on the other side, one more artwork, which is just over here. More fish, because of the miracle of loaves and fishes. Yeah, and then I would like to continue with you and go into the next room where we have actually quite interesting artworks by a German artist called Andreas Slominski. And Andreas Slominski, actually his work, or most of his work, started when he found like a mouse trap in a shop. And he was fascinated by kind of like by the process, how it works and like how it's built, but also about the structure and like the mechanics of this actual mouse trap. But also then it became quite like a philosophical idea for him, and he asked like himself like who places these traps, and he kind of draws like the relation between like human and animals, the kind of the hunter and the victim, but also like the audience and the artist and the artwork and the audience. And he, with that, he always like creates a form of dialogue with the audience. So he wants us to ask questions. He wants us like what this is doing in the museum, and how we kind of relate to this. And he wants us also to question his artworks. So in that, he kind of like or this is kind of the question again, whether he places like traps actually for us, like to kind of fall into a trap of the institution of the museum, and whether we perceive like artworks, or whether we would perceive it as artworks as well in other contexts. And Michael Barcelo, Andreas Slominski, he kind of also says that kind of like actually the idea of being able to place traps for someone or something makes us also human, because humans can place these traps. And he explores that as well, not only in these kind of very classical or kind of artworks that perceive it traps as well, but he also kind of creates these artworks. Oh, sorry, I just need to rearrange a little bit. These artworks that we maybe don't question, or suddenly like don't question anymore just because we see it in a museum context. And this is also with this piece. It's very, very large. So it's also, I think, 2.5 meters times probably 4 meters. And it's just styrofoam. So and this like foam is then painted with acrylic paint and just like patterned and kind of rearranged. And also, the gold shows us that it's something shiny, something worthy probably, but it actually isn't, because it's just very cheap material. But he puts it into this enormous frame, which kind of immediately makes it almost a valuable artwork and a valuable work. And we see it with a kind of like, we look at it with a kind of awe, just because of the size as well. So again, he invites us to, first of all, just perceive it as a first impression, as kind of this massive artwork. But then looking closer, we see that it's just like very cheaply done, and it doesn't have like these kind of strong qualities, and everything isn't gold that shines. So same with here, where we can actually see like that it's just a styrofoam as well, just painted with gold. And another one is, for example, here as well, this little traditional children's trolley with a mouse, a bird trap actually inside, where we kind of walk around. Normally it's placed actually opposite not upside down, but like the other way around. So we first just encounter this like innocent child probably, or we expect like an innocent baby lying inside of it. And then once we get closer, we see that it's actually quite brutal, quite violent, of having this like bird trap inside, where you put like where you put just food in, and then the bird falls inside and is trapped. So what does like Andreas Leminski wants to show us? Like, this is always the question: what does he want us to think of him, but also where he places himself? And this is also another one with the bicycle over here, which obviously like is kind of just a vehicle, so a kind of an object of mobility placed on the wall of the museum, but then hung with all these used bags. And so it's kind of like indication to like an outsider of society, probably a homeless person or something. But then on the other hand, he places himself, like, so he's creating this assemblage, this collage, which places himself actually into like this bicycle, and questioned himself as an artist, as an outsider of society as well, and into the corner of a museum. And with that, I wanted to we're going to skip the next room and question a little bit more about what sculpture is today and how it is differently perceived of different artists as well. And we're going back to the other room that we just passed. And I show you one more actually artwork of Andreas Leminski here on the wall, and you might be able to guess what it is. So it just looks like scrambled eggs. It basically is, just it isn't cooked or anything, because it's like 2 eggs thrown against the wall, which wasn't actually thrown by Andreas Leminski, but by Rafael Jablonka himself, because he's the owner of the artwork, and this artwork gets then like just sold by a certificate, so to kind of to recreate in an exhibition context again and again and again. So it always looks a little bit different, but there's an introduction or like a guidance how to recreate this artwork and how to set it up. So we have here as well this interaction in this museum, eggs thrown against a wall, which is obviously also could be read as a critique of the institution, and just makes us question like where we are and what that means as well, and who's also like taking ownership of this. And with that, I would like to continue to an American artist, Mike Kelly, who is actually also one of a very kind of trusted person, or like friend, or was a friend of Rafael Jablonka. But he's actually, unfortunately, the only artist who passed away already in 2012. So we have one very significant works of his here in the exhibition now. And this is one which he's most famous for, and these are kind of like the stuffed animals. And these stuffed animals became also a trademark of Mike Kelly. He reused them over and over again, kind of conducting very different works. I just wanted to go. So we have like this work here where he sewed together like many different stuffed animals to create this body of childhood experiences, rememberings, and also traumata that he wants to like kind of recreate. And it's not finished yet, so we can almost like pick up the needles and the thread and just recreate it, or like continue doing it. Why does Mike Kelly use this stuffed animals? It's for him, it's kind of this idea of completely innocent child, or like this pseudo child almost, that it's kind of everything it is given, or like this stuffed animals given to a child to live up to something like this, which is this complete innocence, this almost like perfection of just sweetness, cuteness, that a child is given to live after this. But of course, like, children have their own lives, every human being has their own life, so it's never like just just a perfect world. And there's always this paradox or these oppositions as well in childhood, in the child, and also in the stuffed animal. It can be quite like dangerous or like freaky as well. So this actually, the artwork is called Frankenstein, after Shelley's novel. And we see here also like how he kind of, Mike Kelly, then used this idea of a stuffed animal also in a bit more like brutal, honest ways. So we have on the paintings these paintings on the walls here, and on the right side is the yellow banana, in the middle is the green frog, and on the left side is the brown bear. So this is where he kind of used in quite like a brutal way these stuffed animals, dunked them into black acrylic paint, and then started painting with them on paper. So he kind of engaged also with like these childhood memories in different ways, and it becomes quite a dark memory as well, but also a little bit in relation with dark humor. That is kind of like Mike Kelly's idea and gist of the work. I will show you later another artwork of his. But I would like to first go continue a little bit in this room and go to one of the probably most well-known and also like wealthiest contemporary artists at some point in times, and that is Damien Hirst. And Damien Hirst is a British artist born in Bristol in the 50s as well. And Hirst, like Damien Hirst, kind of always kind of placed with these super systems, these hyper systems that are kind of so big and nobody questions them anymore. And this is the art world where he kind of got around it and created his own like entrepreneurial approach in selling directly his artworks from his studio to auction houses and not through galleries where it is normally done. So he's kind of from a very early age on tried to create like different ways in kind of questioning these set structures, but also kind of making a lot of kind of generating a lot of wealth through these works. So while still at the university, he organized an exhibition as well with fellow artists like Tracy Annam and other YBAs, so the young British artists. He's probably the most well-known from the group, but he became very famous very quickly. And in the kind of like around like the 2000s, he was the best earning, highest earning contemporary artist of his time. And this is actually a work, it's titled The Last Supper, where he questions another super system, and that is the pharmaceutical industry. And Hirst says that, for example, like the modern medicine or the pharmaceutical companies is like such a huge system, and it mostly also relies on our belief in it, and we never tend to question it. And so he started working a lot with like empty, maybe you have seen that, like empty pill bottle packets that he exhibited, and just like pills that he just organized in like different frames. And then he took it further and recreated or redesigned these pill boxes or tablet boxes that he kind of trademarked with his name. But when we look at them, we see that they're not kind of paracetamol or ibuprofen or aspirin or anything else, but they're titled like beans and chips or dumplings or sausages or omelette, meatballs, steak and kidney. We have more of these. We have a mushroom over here. And then we have salad tablets, chicken, sandwich, liver bacon, corned beef, Cornish pasty. And these are all actually related to food or meals that are mainly served in kind of canteens or where for the British working class. So quite normal fast food, normal, not healthy or like kind of unhealthy, but normal, quite working class food, because like food especially at the time, it was done in the 90s, is very much connected as well to social class. He later did another one actually where he kind of did it when all these hype around the modern cuisine came up. He did another one with foie gras and kind of like the French delicatessen. But this one is like according to the more like lower income meals. And why does he do it, and how does he connect it to the pharmaceutical industry? Is because Damien Hirst says like we never really question food, and we need it as kind of to survive. But then as well, like these quite unhealthy meals are slowly like kind of getting into our body with the fats and like almost kind of not doing well or doing good for our bodies. And so do also medicine. But we never really question these side effects. And both of these, over the long term, both lead to death. And death is also a very big theme in Damien Hirst's artworks. And we have here, like, I'm going to go a little bit back because then you can see it. This artwork, The Last Supper, consists actually of 12 of these, or like 13 of these tablet boxes. So we have, and this is again like the relation to the title, The Last Supper. We have the relation again to the Gospels, to Jesus' Last Supper, where he dined with 12 apostles. Actually, I have to say to this as well, the mushroom in the middle isn't always termed as Jesus, but like Rafael Jablonka selected him as the middleman here. But they do draw, like, so the kind of these pharmaceutical concept draws also a relation to religion that Damien Hirst often makes. And we have in the middle, like, and you can see like in the middle here, we have an installation called Alone and Yet Together and in Love, which is just a very, very fragile installation with just like 2 glass walls and then an air compressor that holds 2 table tennis balls in the air. And you can just see them floating in the air, and here they're actually dancing a little bit. So they're not always just like standing there, but they're dancing a tiny bit, but they are held up. So this as well is something kind of our fragility in life, and also fragility in these like all these kind of super systems where they are quite fragile in the air, but because we all believe in it and because we all buff, we're still holding up, and they're still like kind of exist and don't break, they don't fall apart. But it is kind of a very unstable complex. And this is kind of the 2 works, very major great works from Damien Hirst in the exhibition My Generation. And I would like to now go on with you to Eric Fischl, and Eric Fischl is in the room that we just like skipped, but I would like to start here with a piece, a painting by Eric Fischl. And this is part of a series called Cringing. And I'm going to say a little bit more about the biography of Eric Fischl in a bit. But this series, Cringing, is a series that Eric Fischl did in response to the 9/11 terror attacks. And why? And Eric Fischl kind of created these paintings of different humans holding kind of the this woman here like holds her hands above her head, kind of cringing together to protect herself. And he draws or like paints these different humans in very different fragile positions where they protect themselves from something. And he wanted to do that because he was one of the first one to react to the disaster. And he wanted to do that he wanted to show the humans, because that was what we kind of didn't see a lot of in this like tragedy, where over 2,000 people died, but we kind of only have the images in our heads from these tower collapses. And he wanted to remind us that this is actually like not an architectural disaster, but a human tragedy. but because we didn't see the bodies, like we probably didn't relate that much to it. And all these discussions in the aftermath were a lot just about rebuilding ground zero, but didn't really focus a lot on or draw attention to all the many, like all the people who have lost their lives. And he always kind of like had these images in his head from people like jumping out of the towers, so kind of like, but very few only that we just like kind of saw one by one, but didn't have like all these masses of like bodies that actually like died during and on the 11th September 2001. So this is part of the series Cringing. And Eric Fischl is actually one of the kind of a friend of Rafael Jablonka as well. So, and they collaborated a lot as well in his artworks. And I'm going to show you one piece of that in a bit. We're going to leave this room for this and go into the next room. And start with Eric Fischl's glassines here. And Eric Fischl is an American artist who was, first of all, started off with actually inspired by the abstract expressionism. And he copied a lot or like kind of went into abstract painting. But then at some point he was not very successful in this. So he never became very successful in that and like didn't really found his way around there. And then he started figurative painting, and this really liberated him because he found a way in that to kind of reconnect his childhood as well, and also relive like a lot of like childhood moments, especially also kind of relive like these traumata because his mother was an alcoholic, and he kind of like reworked these relationships of also like this American kind of American way of life, or like his kind of American reality in that. And he started working actually with a lot of like collaging. So each protagonist, each person, each object had their own like kind of sheet of paper, or like these glassines, so a little bit transparent paper, that all of them could be rearranged like storyboard, and kind of like a film set as well. And this became Eric Fischer's way also to kind of dig deeper into these stories and recreate them. And he did that then also on canvas. So we see here, for example, Catboy, where we have again these different canvases that can be like put together in different ways. We have here like the pumpkin in the front. That's also like this kind of adultery, but we see that it's kind of carved out as well. It's cut open. And then in the background, we have this giant cat with a big smile. So quite frightening, actually, but quite like, kind of almost like a dark, humoristic approach. And then if we look closer, we see within this cat costume, I'll zoom in, within that cat costume, a face of a boy. And that boy is directly looking at us, like directly looking into our eyes, and looks quite frightened, so quite shy, who is like just put into that costume and like put almost into that protective layer. So this vulnerability is always an aspect in Eric Fischl's paintings, and he doesn't really create or like shows us these whole stories, but more like these fragments, like these moments of a story, where you kind of want to know like more, or wanted to know what happened before or after, but we just have this one like snapshot of what's going on. And with that, I would like to go into the next room and show you like one of these collaborative projects with Rafael Jablonka. And this is this one. And it's titled the Krefeld Project. And Krefeld is a town in Germany where a house from Ludwig Mies van der Rohe, the architect, is. And Rafael Jablonka And Eric Fischel furnished this whole house for 3 days, and then they put 2 actors into the house and asked them to play just scenes of a relationship. So quite like everyday scenes of this human relationship. And Eric Fischel, it was quite an effort to put all of this up. So kind of Rafael Jablonka was very surprised when Eric Fischel only came with a tiny camera and not like a whole camera setup. But he took like over 2,000 pictures of these 2 actors interacting in these like everyday life. And these became then the source of like lots of new paintings. And he's showing us here is what he is showing us here, sorry, is just like this, yeah, this almost normal everyday life, normal everyday relationship. But we glimpse into that, and we kind of like we get an insight into like the kind of the human interaction and the relationship between these 2 actors or 2 people. And we can almost put like these actors um, into kind of like as a question almost, because as you can see here, for example, that these actors then became like these couples so much that they didn't really act it out anymore. Like they really embodied that scenery. So you can see also like the actor laying in the background, he has like an erection on that painting, and it was actually like in reality like this as well. So Eric Fischer was fascinated by the fact that this becomes like a new reality. And he wanted to capture this like strange setup reality that is so real, even though it is acted out. And we have another one, which actually is Jablonka's favorite image or painting here, where we again have this relationship between 2 people, and we don't really know what's going on here, but we see that somehow they are in relation to each other. We don't see like the face of the bride in the foreground, and we don't really know what the woman is saying in the background. She could be saying like, "Oh, I'm so happy, you look so beautiful," or she could say, "Please don't marry him." We don't know. But he's just like kind of bearing. He's just bringing it to the surface, like these short interactions where we kind of only can very much guess the story around it. Jablonka says that this is also a kind of a love affair, or kind of where a painting where Eric Fischel confesses his love to the color of white, because it is so white, like this white is really glowing, and it's very highlighting it's really highlighted in this whole image. And so he draws like a lot of kind of connections as well to art history, with like the white of Edouard Manet and the blue of Giotto. But also actually this painting appeared in Jablonka's dream, where suddenly like the bride in the foreground appeared as an angel, actually kind of talking to the Virgin Mary, actually, and kind of became just like this scene of enlightenment almost. So Eric Fischel shows us these fragments of stories, and this is where I would like to continue the tour with you. And I'm going to skip the next room to have a little bit more time. And we're now going to see another artist she is also an American artist, and she is also kind of like really questioning the institution, and you have to see her artworks with a little bit of irony, because the artist is called Cheryl Levine. And Cheryl Levine worked in the 80s, where it was a lot like this this idea of that after modernity, and like after kind of the art from the French impressionism and expressionism, like there wasn't anything else to just innovate or like to just invent in the art world. So what Sherry Levine did is just copy basically all these like masculine or like these male heroes that she kind of encountered in her like study of art history. And you might have seen already like the urinal of Marcel Duchamp that was placed, or that Marcel Duchamp placed this like ready-made as a urinal in a museum in 1917. And there he showed that actually only this context of the museum, only like the kind of the museum as an institution that houses the artworks makes it an artwork. And this is what Sherry Levine shows us here as well. She copied this. She did it in gold, which shows also, that's like this kind of value of the art. It's not actually gold. It's actually not copper. Brass. I think brass. I think it's the English word. And she titles it so like Marcel Duchamp's artwork is titled Fountain, and Sherry Levine's artwork is titled Fountain, in brackets Buddha. So with a little bit of imagination, you might be able to see a little bit of like the silhouette of a Buddha figure. But you can also like draw the relation. If you don't see it, don't worry, it's fine. But maybe you see also like then kind of you can just draw the relation as well again to this holiness in the art. Like that kind of art can almost becomes like a form of religion as well. Maybe we can think about there, like again about Damien Hirst systems and like the systems of belief, and that kind of the belief in that makes it what like gives it its power as well. And I'll show you I can actually show you this one as well. This is one of the first artworks of Sherry Levine, where she which is after Walker Evans, and Walker Evans photographed like the quite like poor working class in the southern states of America. And Sherry Levine photographed, or like went to the exhibition, got the exhibition catalog and photographed the exhibition catalog, so these photographs from Walker Evans, and then exhibited them as her own. So she kind of almost saw, especially like this idea of photography, almost as an invitation to reproduce these artworks and to make more of them, and then kind of to take them and make them as her own. She also did, for example, here in she melted together all the colors of like Yves Klein paintings into one, and just like caused a meltdown, so to become like one kind of blurred image of these of these famous or like these French artworks. And here's also Monet, Monet's Cathedral in Rouen, which was one very kind of significant Impressionist series where Monet painted the cathedral in very different daylight to show how the light is changing, how the colors is changing, and are changing. And Sherry Levine just makes it and prints them, photographs them and prints them in black and white. So she kind of gets rid of what is actually like the core essence of Monet's paintings, and just like reduces them to merely the strokes, or to merely the image, but doesn't show actually the colors and the light, what is like part of the Impressionism. And therefore she kind of reduces it and loses almost this heroic essence of the painters. And she also kind of completed this whole series of Monet's Cathedral. Yeah, and then we go on to Philip Taft, also an American artist who does these like. Oh, what I can say also to Sherry Levine, she in that, like with this, it's kind of a whole genre, and the genre is called appropriation art. And she is one of the pioneers of that, and like it's become actually one of the significant figures in that. But also, for example, Philip Taft uses a little bit or has this element of appropriation art in his works as well, because of this one is actually very, very similar to a painting by Clifford Still, so also an abstract expressionist, an American painter, who was then whose painting then he kind of almost did as a ritual and also recreated because he admired it so much, but still did it in his own way. He did like alter it a little bit in adding these ornaments around in the red. You can see like it's not pure red, it's just like different shapes as well, that's put together to create this painting. And Philip Taft gets, just collects actually all around him in his environment, like these different forms and shapes that then create like new paintings that are just done layer by layer by layer, printed on the canvas to put together. And for example, we have that here in this one as well. If we zoom in, we can see these spirals and these curves, different curves, but also shapes and kind of different lines, but also different shapes and forms. And this is a huge painting. Rafael Jablonka actually didn't want to buy it because it was so big, but he couldn't resist. So he has it now in his collection as well. It was done actually for an exhibition in 1996 in the Viennese Station, so here in Vienna. And what he does here is kind of like the red forms and like the flat surfaces are drawn from African wood sculptures. So we have here like this element of these, these kind of cultural spaces, also antique forms. And then we have these like curves and lines in the background that he actually copied from an iron fence in Capri that he saw. So he put like these very, very different elements together to build up layer by layer his paintings. It's called Metropolis, so this giant city, and also he kind of combines there this form of chaos and the form of structure, like within one or order, chaos and order within this one piece. And I would like to go now to the next room before we go upstairs, like quickly as well, to show you here one big sculpture by Richard Deacon, who is a British artist, and he calls himself actually, or he titles himself not as a fabricator of different elements, of different materials as well. So you can see here this oak wood that is twisted under steam. So it's not carved out, it's actually twisted with the aid of steam. And then he combines that with quite shiny metal. So he has here like these this contradiction as well, or this paradox of like very quite organic material and then very stiff material, so the metal and the wood, but then also of light absorbent material, the wood again, and then reflective material, the metal. And the sculpture is titled Dead Leg. And we have the leg here on the right hand side. This is like kind of the dead leg, because he says like when it's dead, like something, or death is just like a straight line. It's nothing moves. It's just stiff and still. And then coming out of this out of the dead leg is this twisted wood that goes all around the room, just until the end of the room, and then turns again, and goes back actually to this dead leg. So it's actually a continuous line. It doesn't it doesn't have a beginning or an end, or just like it has it here in the stead leg. It doesn't end in the end of the room. So here we see as well, like the kind of the life coming out of death and then going all around, like as almost like a roller coaster around the room, and then ending in death as well again. Yes, and now we're downstairs. We're finished downstairs. I just want to quickly show you one artwork upstairs where we just switch, switch. We go upstairs again. We've just been here for, so we switch floors, and then go a little bit around the Albertina. So you get an insight into the museum as well. And we walk over the red carpet, and then we'll go into the next exhibition room here on the left side, and this is where my generation continues. And I just wanted to finish with one last artwork of Mike Kelly, the American artist that did the stuffed animals downstairs. And we just have one other artwork here, which is Kandor. And Kandor is actually Superman's birthplace, where, and in the story it was that like Kandor was then minimized or shrinked in size by the villain Brainiac and put into a bottle. And Brainiac conserved all of these bottles, but Superman managed to actually get hold of the bottle with Kandor, so his birthplace. And this is also kind of Superman's relationship, or like kind of holding on to the childhood, to his like birthplace. And it's kind of on one hand, it's protected in this glass bottle, but then it's also like encaved and imprisoned in this glass. And Mike Kelly recreated the city. It's actually just resin, and he recreated it from he collected from all the Superman comic books there are, like images, to then to recreate the place, and the kind of the ones or the parts of the city he couldn't find images for, he just like left out. And he actually has made another artwork where he built like models from all of his past schools, and the parts he couldn't remember, he left out as well. So he's kind of playing as well with this idea of like remembering kind of experiences, childhood traumata, and what you remember from your childhood and what you don't. And this is like pretty empty spaces, like vacuums in your memory as well. And this is also was kind of like a collaborative project, because these bottles were actually fabricated in Poland in a glass manufacturing fabric that made also like the biggest wine bottle in the world. And then they were then like just like fabricated in the factory and then shipped into to America to then kind of color them, and then kind of brought back. So it's kind of Jablonka has been a lot of like involved in these artworks as well, and kind of help the artists to realize their projects. And with that, we're coming to the end of our exhibition tour. I hope you enjoyed it. I've just seen that there's something in the chat, so I'm just going to stop sharing my screen now. But if you want to, you can always visit the Albertina website, and there's like the virtual tour online as well, so you can like revisit the exhibition then as well. And I'll just stop this and then go into the chat. Okay, so I've just seen that there are like no extra questions, but that there was just like someone wondering whether the eggs have on the wall include some smell. No, they don't smell. I was surprised by this as well, but they're actually not smelling. So I guess that's actually quite good for us. But yeah. Okay, but perfect. Then I think yes, please feel free to come to the Albertina soon as again. Like, I hope we will be open from next week on, and it would be lovely to see you here, of course. And the exhibition in my generation is actually on until February. So if you are interested in that, please do feel free to visit. And yeah, as I said, like the virtual tour is also on the website. If you're interested in specific facts or just want to look at something again, you can do that yourself as well. Yeah, and perfect. Then I'm wishing you, a great rest of the conference, a great rest of the week, and thank you very much for your time. And I hope, Merry Christmas. That might be the first time, and Happy New Year, and all the best. Stay safe. Bye.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
When magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day. Then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
So, we are back and I hope you enjoyed our tour of the Albertina and afterwards a nice virtual coffee break at Sacher. But now let's get back to business. We are talking about RP in the public sector, and of course it will not be me. This is why we brought somebody who really knows something to tell about this. It's Clemens from the Austrian Federal Computing Center, or BRZ as the German speaking people say. Hi Clemens.
Hello, good afternoon. Great to be here.
That's good. So, how do we make our customers happy? This is the question you will answer?
I hope so. We are also a service organization, so this is why customer success is critical for us. And more importantly, obviously, we are serving nearly 9 million Austrians and 1 million plus enterprises in Austria. So this is our customer base or user base, let's say.
Okay, so I will leave the stage all to you. and we'll come back for the Q&A. Everybody, please use Slido to ask questions, so that Clemens has a lot to answer at the end. He is very keen on questions, he told me.
Yeah, I'll present briefly, what we do as a company, and also what we do in RPA. We don't sell anything to you. Essentially, we are owned by the Federal Republic of Austria, and this is our principal client in the end. And what we do is pretty much all of IT and technology requirements of the federal ministries are actually developed by our colleagues. What you can see is essentially last year's figures show you we are around 1,300 people strong, 317 million euros in revenues. Why is that relevant? Because we are actually a public limited company and not some federal agency, but really a private sector organized limited company. And our main market is actually federal ministries, the federal chancellery, and other top bodies of government, including obviously also spin-off organizations like the agency IMS, for instance, is the principal client. And we also do quite a bit in universities. We have a really long history in Austria and are very proud to be top 3 in the e-government benchmark in the entire world. We have made a few number ones in the sense of world's first launches on critical projects. For instance, we have, I think, very strong one-stop shop and no-stop shop solutions. And I'm very proud that we actually have this kind of technology in service, and also customers that really try to push us to the leading edge of technology. Last year, for instance, we launched also an app that is essentially a one-stop shop for Austrian citizens, where they can do a lot of e-government processes. And we are continuously building on that and are going to launch this year and in first quarter of next year quite a few exciting things. Also, the COVID-19 pandemic was a principal driver of our work this year. So at the beginning in March, when really the crisis hit Austria, we actually started first to ensure that a lot of federal employees are actually able to work in home office. So that was really focused on infrastructure services, enlarging VPN numbers by significant numbers over a weekend, or rolling out laptops to people that actually used to work on a desktop at their office. And then over the summer and also now in autumn, we are working extensively on providing on a very short time frame applications and business processes that actually allow the Austrian government and most importantly the economy of Austria to really get through this enormous crisis. So from public health records to tax fraud fighting and very large platforms where there is interaction between government and citizens as well as companies, we do a very large set of things for the Austrian population. Some of the lighthouse projects I think that are relevant here also in this context are the things that we do around innovation. And it's really also new times in public IT. So these are very innovative things. RPA is a critical technology that we'd like to actually roll out on a large scale. We also have blockchain and cognitive analytics, for instance, quite a few interesting initiatives. But we also do very large scale individual software development. So for instance, right now we have a huge project with more than 8 Scrum teams working in the safe framework for the customs authorities in Austria. And that's quite a challenge because we actually started a good part of this project right in February. So one of the first PI plannings actually was planned to be obviously on site, and we had to find a new way of working because since March, a large part of our organization is actually in home office work. So we had to build the entire idea of a PI planning in digital tools. And I think we can be very proud of the fact that we first actually realized that, and secondly, also have very strong velocity in that process. So also we as an organization had to learn new ways, and these are very large scale projects that we do. So that's great fun because you actually see it's a very big wheel that you can actually turn when you work on federal topics, and that's super exciting. And I think that also is what I'd love to talk about today as one of the examples where I think there's a huge lever that we could actually use, and that is robotic process automation. But before we actually dive into technology, I'd like to show you what the problem actually is. So what you can see is we have 136,000 federal employees, and 46,000 of them actually work in administration. So that's a fair part of the total payroll, and also it's quite a sizable number of people. So meaning that this is it's like a big international company that actually works in an office setting. And what you can see here is actually that this group of people is in terms of age structure 10 years older than in the private sector. And obviously, this is all tax money, and we do not want to spend that unwisely. So this is why actually the federal government of Austria already many years back in the mid-2010s actually decided that only each and every third retiree is going to be replaced with a new hire. So that puts a lot of pressure on the total amount of workforce that is available and the total amount of hours that actually are there in the sense of capacity. So the age structure and that policy of not really hiring, rehiring everyone that is retiring means that in the next 5 to 8 years, nearly half of the workforce in administration is going to be not available in future. And that means that there are two ways or two critical issues with it. First, there's a lot of know-how that is actually retiring with these employees, and a lot of capacity. And since the complexity of our world isn't decreasing, and also actually the number of Austrians isn't decreasing either, it means that there is continuously more work for federal employees in administration. So what is the solution? In our view, the solution is clearly that we should look at automation. So what you see here is roughly what type of activities there are in public services. So there's a bit of leadership, that's people management. There is a technical know-how that you need to employ to solve really complex project problems or take decisions. Then there is planned and unplanned physical work, but that's only a small part of overall activities, as you can see. Data processing, data entry, and communication. And when you look at the share of these activities within total working hours, that's the 63% of that total available working hours of public administration employees. You can see that half of that time actually is, according to a study of a consulting company, has the potential to be automated. So when you sum those two figures, you can see that a third of total working hours could essentially be addressed by process automation. What are the benefits? Obviously, you know, it's much more enjoyable to actually do things that are exciting and also meaningful and need real human intervention. So employee satisfaction in process automation is typically quite extensive. So once individual teams that start to actually work on process automation and use these tools and actually get rid of very stupid and unfulfilling repetitive tasks, actually see, wow, where could I actually employ that tool as well, and are really creative on trying to find new ways of and new use cases. So once that first difficulty or challenge in implementing such a tool, because it's new and it's uncertain, is this actually going to steal part of my workforce? So, you know, there are some thoughts around that at the beginning, but then once you can see how great it is to use that kind of tool and that there is no single employee losing his or her job because of such a tool, but actually the work gets more enjoyable, you can see lots of traction. Then obviously, these tools are actually 7 times 24 hours available, so you can do much more in less time, also quite important. And then the users of these processes and also the subject of these processes, like the citizens and companies, are going to see that things are moving much quicker, also a huge benefit. What we could see in terms of challenges is surely that finding the place where to use actually RPA and process automation is really difficult because you need to be sure that you're not solving a little problem and that only comes and goes every once in a while, but you actually want to look at a lot of volume tasks, for instance. So identifying the right use case isn't trivial. And then also getting everyone on board internally and externally to actually solve that puzzle is another main challenge. Yeah, I think on the opportunities, I'd like to expand a bit later. So what kind of use case is ideal? First, obviously, those that are complex and are covered in large-scale applications and systems are not those that you really want to tackle because it's too complicated. You would need to do too much rules, and it's often faster and easier to actually implement new features in these large-scale systems and applications rather than building a robotic solution around it. So specialist solutions aren't great either for the obvious reasons. So where is robotics really powerful? It's essentially when tasks and the process value is low and the task is quite simple. So there you can do automation. Ideally, as said, it's repetitive, high volume. It also has a fair degree of rule-based and not a lot of human judgment required. So you can actually make a one-size-fits-all process tree and then run this through. Also ideal are structured data rather than unstructured data. And what we've also seen is it's important that it's not just within one system and you're automating one system, but ideally it's at least 2 or more systems that you try to bridge through such a technology. Benefits are quite obvious also. I think I'll leave you to read this at a later point. So what we've seen is right now, industry really focuses on RPA, so robotic process automation, and that is software robots. So essentially, it's like a human on the interface of on the user interface, and also often actually implemented like a real person in the sense of that the robot needs to have access to computer systems and thus actually gets an employee number. And with that employee number, the robot is ideally identified and then works pretty much the same way as a regular clerk would, but much faster and with potentially also quite a bit less mistakes. Second stage, when you actually have already a bit semi-structured data, what we have seen is that you can augment RPA with other technologies. And here, for instance, natural language processing and also crawling, for instance, is something that makes a big change to the performance of such process automation tools. And then the highest class, essentially, in our view, is automating processes through self-learning systems. And I'm going to show you two interesting examples of where such a technology actually is available. And we actually see rather rule-based robotics. That's very much what RPA stands for. And then we try to coin this cognitive robotics, where we actually add a certain degree of capabilities through machine learning, or for instance, computer vision, or also text-to-speech, speech-to-text capabilities. And therefore, combining these two, RPA and AI, is quite powerful. And you're going to see how we do that. So think of a situation where you are a federal employee working on a case. So essentially, at the front end, we already deployed quite a few tools like chatbots, for instance, are, I think, live now on 5 different federal ministry websites. And in particular, through the Corona crisis, this was quite critical because there was a lot of incoming calls in regards to the employee, to the workplace and company situations. You know, how do we solve that crisis on a company perspective? Also, healthcare related questions. And here, really, it was important to actually have some degree of automation. But then there are actually a few specific requests or tasks actually that come through. And what we would do here is essentially use a virtual assistant that actually just brings to awareness of the clerk those cases that actually need intervention already with a recommended decision, and the system analyzes that based on the inputs that were provided. And the decision power, and that's very important, I think, in the public sector, really relies with the clerk, the federal employee, and not some algorithm. I think that's very important because we do take care of very sensitive data, and the decisions actually have a significant impact. And as such, I think virtual assistants in the public sector should always have the ultimate decision power with the clerk or the employee of the government. In the end, when you follow that recommended next action, then that can be executed, that decision can be executed again by an automated system. If for some very important reason, this recommended decision for that case wasn't the right one, then we can start a learning process and add and enrich again, the algorithms that stand behind it, and deliver for the next case actually better decisions again. And that's the kind of idea how we would actually see virtual assistants to operate in the public sector. So to make it a bit more concrete, I'd love to show you 2 very concrete examples. Obviously, we have quite a bit of data and information on companies, on individual people, and this comes through different channels and different IT systems to specific organizations within the federal government. So data cleansing is a huge theme. And here, for instance, is a case where we actually rolled out robotic process automation to actually help in that. So in the end, there are, from different tools and different times, essentially on 1.6 million data objects, and that's essentially people, actually 2 different numbers available. And the idea was to actually harmonize those numbers. And these cases, 1.6 million cases, every time one of these people actually is treated one way or the other in a tax perspective, then a clerk actually opens that file, looks at the two different numbers and merges those two numbers. And then it becomes one data entry. So that's tedious work that is actually done over a long period of time and only when sort of opportunistically. So what we said, let's actually not do that this way, but let's speed up that process. So we actually developed an RPA solution for it. And we are currently still, but close to the finish line of processing these 1.6 million data objects and harmonizing those. And you can just see the enormous speed increase and quality increase that we could actually reach. So we are having 5 robots that actually work continuously on that. And in 3/4 of a year, we were able to actually close this. What would have actually taken 33 years if it was one employee. Obviously, more people are working on it. But still, there's a massive gain in productivity, and it's really very boring and uninspiring work. So I think that also meant that we freed up 33 years of boredom. And this is something where you can see the power of technology. And you might think of, why is it 16 hours a day that that robot is working? Well, it's not because they are unionized labor, but actually we have in these systems that we actually address through this RPA solution at specific points in time during the day, they have very high load. So this is why we don't want to charge them extra with another 5 robots working on it in a significant speed, actually. So generating much more traffic than 5 humans would be. So these are the reasons, for instance, why it's not a 24/7 use case here in this case. Another very interesting, and I mentioned that before, relevant case is actually taking robotic process automation to a new level by also adding specific machine learning procedures. So what we do here is actually matching one database or register with the other. So you have actually a tax register of companies, and then there is a company register. So basically, it's in each and every country you actually have a company register and also a tax register. But the point is, it's done periodically and automatically, that matching of the two registers. But the thing is, there are still 20,000 really complex cases that have to be matched manually each and every year. So again, you can see that requires some degree of human judgment, but the human judgment really is around which steps to follow to match those two registers or the case within those two registers specifically. So what we actually did here was we added a machine learning component that would actually look at which ideal process steps would be taken first, second, third to actually bring that complex task to an end. And we've seen that this is a very powerful solution to also speed up time of clerks and make those very boring tasks actually rather the headache of a robot than that of a federal employee. And you can also see the time, a complex case would take significantly longer than 40 seconds, which is now the processing time of this solution. So how do we approach those projects? Obviously, process automation means you need to have a process to do it, and this is ours. So what we try to do is, in a very short time frame of roughly 10 to 14 weeks of time in total, actually go from assessment, is that case something that we can do, developing a rough concept of how it could be implemented, then implementing and go live in the implementation phase. So you can see it's not something where we do a lot of cycles of endless concept development or also coding, but rather here it's really about customizing the tool and playing through that process and implementing it on a very fast basis. And I think my vision, at least for this tool and this type of work, is actually that the respective teams themselves are able to ultimately, after the first robot is implemented, to take that tool and build these things themselves, so that it's not an IT guy or a developer that has to do it, but rather that the teams that suffer of those repetitive tasks are actually able to really do this kind of work themselves and use the power of this solution and take it in their own hands. So in summary, there is significant potential in terms of working hours in the federal administration in Austria, but basically in any other administrative organization available. So we estimate that at up to 30% of total working hours, so that's substantial. The tools that are there are really powerful, and the technology is ripe, so you can use it today. It's no need to actually run through proof of concept or limited tests or pilots, but really you can roll this technology out and actually build large-scale solutions and also have large-scale benefits. When you take that to the next level, as we try to do it here at the BRZ, it's, I think, virtual assistant is the better word for it. It's not just RPA copying data from one system to the next, but actually involving also input information and output of information that is automated, that really then is a game changer in the overall perspective, because then you're tackling the entire process and not just individual steps of it. And when, working together and trying to combine different approaches, then obviously you get the biggest results. So I hope I was able to give you a short overview of what the topic is and why it is so important for us and our customers. And if you're interested in these themes, then I strongly encourage you to look up on our website whether there is something that really fits also your profile. We are actively recruiting. And as I mentioned, we do substantial agile development projects. It's, I think, great fun to work on these. You can see each and every day the impact that you can make on an entire country. And that's what keeps me super motivated and gets me out of bed every day to say we can really change the lives of 9 million people and a lot of entrepreneurs in Austria. And this is, I think, quite exciting also in terms of technology that we use and topics that we work on. Stefan, I think over to you for the Q&A.
Bing! Like the genie out of the bottle. Thank you, Clemens, for this cool and entertaining talk. I thought I already know everything about BRZ because I use it a lot. And thanks to Clemens and everybody at BRZ, I saved a lot of my hair in Corona due to all these digital available processes which already exist. And I'm not only talking about Elga, and you might need the recipe.
Yeah.
So, and here come the questions. Sandra wants to know, do you see ethical challenges around AI and RPA?
Great question. As I mentioned, I think it's really important to know where the decision is actually taken and what the impact of technology can have on such decisions. And in the federal context, the impact of decisions is so vast and so invasive into private life and personal future that I think there the question of ethics is absolutely critical. This is why in another initiative, actually, we have been working with the European Commission and also a number of international organizations over the last 1.5 years on exactly that, trustworthy AI. We've been partner of the European Commission in developing that framework. And we have been developing an own assessment framework and risk assessment framework around trustworthy AI, which we actually are employing for any of these projects where algorithms are actually used. So we are also actively consulting our customers, so the federal ministries, on exactly that question, but in a way that it is structured. So we have 5 dimensions that we run through, but you can see more details on that on our website. But it's quite a comprehensive assessment framework to ensure that the algorithmic decision-making system actually results in trustworthy decisions.
Mm-hmm. Thank you. So, and Markus has a question which is really interesting to me. How do you prioritize the use cases to implement? Is it based on a first come, first serve? Or do you implement use cases with the highest potential first?
Another great question. So for now, it's first come, first serve. Really, it's our customers that need to see that they have a need for this kind of solution. So we try to actively show them the potential. But for now, it is first come, first serve. But I think that the biggest impact, obviously, we could do if it would have a more structured approach. And in the current program of the current government, there is actually an own sentence in it, so an initiative that would yield to exactly that point. So a structured way of implementing RPA and yielding the benefits. I think they are quite far in defining how they want to do it. So as of end of this year, beginning of next year, this theme is going to see much more traction and in a very structured way, meaning that what are our use cases for it? What's the impact that we can have with that use case? And then ordering them in order of priority.
Mm-hmm. Okay, then my favorite questioner, Mr. or Mrs. Anonymous, does the RPA also create new job profiles which are different than the existent ones?
So in our case, absolutely, because it's a new theme. So we actually have within my area, it's digital advisory. It's our consulting part of the company. We actually have digital consultants, and they are certified management consultants, and they actually work on exactly those topics. So that would be, I'd say, incremental job. And I think that in the context that I tried to describe to you earlier, when there is decline in workforce built into the system, then this is also not a threat to employees, to current employees. It really is actually making the daily work life more enjoyable when using that kind of technology.
That's true. Who doesn't like a good tool?
Yeah. If it works.
Oh, favorite question. Does it work? Yeah. And Markus has the last question, which is in at the moment. Which RPA tool did you use to automate the use case with the 1.6 million data objects?
Yeah. So we actually are subject to very strict public procurement laws. So it's always difficult, to have a broad set of tools available to us. So we need to see that we can actually procure them. And in this sense, we actually worked with Automation Anywhere for this use case, and we've been quite happy with this. But we are actively also looking at other opportunities and other tools. There is a very large number of companies active in this segment. It's really difficult to keep track of what's happening there. So we have an own team at the BRZ that looks at these kind of technology changes. But for now, we actually use Automation Anywhere. In a proof of concept, we also looked at UiPath and Blue Prism, and but we weren't able to actually use those tools at the time to really scale it beyond something that is actually a testing of the tool.
Mm-hmm. Okay. So cool. We are out of questions, which only leaves me with this last thing. Before the stream started, we were also talking about, or you were talking about that you are working in this SAFE project, which I think this is am I allowed to say sexy? Is this according to the code of conduct? Okay, yes. So it sounds very sexy, but how is the impact from your point of view when you work in this large agile project? How is the impact on your relationship with your coworkers? Does it bring in complete new structures, which are below the radar because there are always some there, or is it just another way to do business?
Yeah, I think contrary to what you might think of public IT, a substantial part of our individual software development activities is actually agile. Because I think it's also the most enjoyable way of bringing IT to life. Because very strong self-determination by the team, self-organization is possible. It's also for the customer ideal because they can change and see, what is happening on a very close basis. They can also steer from a content perspective. I think that's for all sides. It's very enjoyable to do this kind of use this methodology. Our challenge is that typically the size of the software that we develop and the projects are huge, because the complexity in business processes that we have to actually build into this software is enormous. Yeah. And as such, the number of people that we need for such a large scale project, is also huge. So it's not one Scrum team that works on a specific niche thing, but we actually have 8 Scrum teams working on one big software, and it needs to have big releases and times when you can check in again on where you stand with this project. So that's why we actually increasingly saw the limits of Kanban and Scrum in this sense. This is why we were quite excited when we saw that SAFE would be able to allow us to structure this significant number of people and the complexity of those tasks in a much better way. So Scaled Agile Framework is actually our preferred and company-wide development framework. And also for us, that was a big learning, because in the end, SAFE itself is a framework, and you can see, it makes sense in itself, but we are an IT provider, so a service provider in that sense. So we are not Microsoft or Google that actually can structure the entire company along that framework and produce its own products. So we always need to also phase in our customers into that framework of scaled agile. And as such, that wasn't trivial to also make it work for us with our line organization, with our customer and IT provider perspective. But I think now we managed. It was a huge learning. We didn't have much time also to adapt it to the digital world, but it's certainly the most enjoyable way of working. And we saw that the current sort of setting that everyone or a large part of the of staff works at home, that this makes us actually more efficient in these large scale projects, because it seems that people are more focused and less interrupted when they are at home. Except for when you have 2 children in the age of 8 to 10 like mine that have constant questions on homeschooling matters.
Oh yeah, this is the please do my homework for me situation. Okay, so thank you, Clemens, and
you're welcome.
Another big shout out to the whole team, and we will be right back after a short loop with Ingo, who will train us in excellence. I'm looking forward to that. Okay.
Thanks for having me. Have a great day. Goodbye.
Thank you, Clemens. See you soon, hopefully.
Yes, absolutely. Goodbye.
Bye-bye. Yeah. Good joke. We had that already. Okay. Okay, apparently my colleagues love to trick me and I'm really live. Because I think they also wanted to show you this magazine, the whole pride of the team. And I wanted to read this article from Alexandra Waldherr on quantum computing because I saw her talking and she's young and brilliant and enough advertisement. No, not enough. Okay, let's do it like it should be. This magazine.
magnetic fields move and electrons start flowing. When you feel that anything is possible. When the night can turn into day, then a new modern world is possible. Electricity gives impulse to our imagination. Passion and precision are at the heart of our work. Anytime.
Illwerke VKW. Energie für Generationen.
Your app just crashed. It was struck by a hammer manufactured in 2005 by Harry's Hammers. The hammer's head is composed of 75% nickel, 20% steel, and 5% iron. Curiously, a hurricane just came down in Iran.
I'm waiting for the guy in production to kick me that I know I'm live. Hi Ingo, and hi audience. Welcome to the last talk of today. It really is great. It's the last talk, and it's Ingo, a guy I know for very long and where I always loved the stories. It's not the stories where you will fall asleep, you can trust me on this. And today, Ingo, you're going to tell us about excellent software testing. So I think I better mute my camera and microphone and take my popcorn and enjoy this show. So the stage is all yours.
Thank you so much, Stefan, for this terrific introduction. And of course, many thanks to all of you for joining. I'm Ingo, as said, and today's session, without a big surprise, is all about software testing. And this talk comes in two parts. In part one, I want to share, my notion of software testing. I want to let you know what software testing means to me. That will be part one. And in part two, I want to share some characteristics that make software testing excellent from my naive perspective. So that's the simple logic behind this talk. That's the master plan. I hope that works for you. So let's dive right in. The more and more I'm studying the field of software testing, the more I learn that software testing is like a deodorant. And the reason for this is fairly simple, because the people who really need it never use it. And that's exactly the reason why I'm here today, because I want to change that. And to do that, I want to say some words about my person first. In the last 10 years, I've worked as a product manager for several tool vendors in the automation space. In RPA, that means robotic process automation, and in automation for the purpose of software testing. So I lived and breathed automation. Automation was my daily bread. It was at the epicenter of my professional life, so to say. It truly dominated my daily thinking. And all this told me one important fact about software testing, and that is that I should rather see tools as classes. So by designing tools for the purpose of automation in testing, and by observing what software testers actually do, I learned that tools do not test, just as classes do not see. So tools only help us to test, just as classes only help us to see. Or in other words, the classes don't do the seeing, just as the tools don't do the testing. So the bottom line is that testing is something that doesn't happen in our tools. It's something that happens in our heads. It's a thinking activity. And for that simple reason, I do not reduce testing to an act of artifact management, where you use tools to create, to automate, to execute, and to maintain test cases, for example. Testing to me is so much more than that. And therefore, I like to say that testing is no more about tools than astronomy is about telescopes. And if we would reduce the act of testing to an act of test case creation, and especially test case automation, then I think we also would need to accept the fact that when we are testing badly, would just help us to test badly at an accelerated rate, right? So this means that we need to avoid to automate chaos, because if you automate chaos, all you get is faster chaos. And this usually looks like that. So here is a typical software testing timeline. And this software testing timeline is usually composed of 4 phases. Now, in the first phase, I hear people saying testing, never heard of that. There is only automation. We automate everything. Now, it usually takes some time until those people then start falling down what I like to call the Mount Stupid of software testing. And it's a huge mountain, trust me. But when those people then start falling down that Mount Stupid, they immerse into what I like to call the valley of despair. And in that valley of despair, I hear those people saying, okay, there is testing, and testing is probably more than just automation, but we're just not convinced that we really need it. And you know what? The last 2 phases then often look like this. So now let's zoom into those last 2 phases to see what's really going on there. And now I need your imagination. Imagine that all these dots you see now on that slide represent all the test cases you have, for example, in your regression test portfolio. And now imagine that all these test cases pass in the last regression test run before you decide to ship your product into production. And then you might conclude, well, that looks good, right? So let's ship it. Let's ship our software product. And that is what you then most probably will do. But just a second later, you will see something like this. You will see that repetitive test case execution, no matter if it's done by machines or by humans, is by far not enough to avoid scenarios like that. Now, this is usually the point in time where people start realizing that testing shouldn't be confused with test cases. These people start realizing that testing shouldn't be reduced to the act of creating, automating, and executing test cases. Testing is so much more than that. So now let's dive a little bit deeper into the subject of software testing to understand that a little bit better. And to do that, I need your imagination again. So now imagine that this black rectangle shown on the right-hand side now represents your software product. And it represents the entire functional and non-functional spectrum of your software. And it also represents all the environments your software can be situated in. And it also represents all the people that might use your software. So that's all there is. That's all you could possibly know about your software. Try to imagine that. Now then, the green rectangle represents all what you currently know about your software. And this rectangle is much smaller than the previous one because it's simply impossible to always know everything about your software down to the very last detail, right? Then the red rectangle represents everything you repeatedly check in your software. For example, by automated repetitive regression checking. And again, you will never be able to check everything you know at any time because of the time, the resource, and the budget constraints you are confronted with, every single moment in your daily testing business. And so the question here is, well, would it make sense to try to automate, to codify all your knowledge? Well, most people would say, yes, of course, that's the ultimate goal of software testing. But I'm saying no, because when you would only aim to automate all your knowledge, then the question is, well, how on earth would you then be able to create new knowledge about the software? And you have to create new knowledge about your software because your software constantly grows. And so you constantly need to create new knowledge about your software to reveal all the problems in your software that are far, far outside your checking regime. Now, that is what software testing is all about, at least to me. Testing is all about closing this knowledge gap. It's all about closing the gap between what we know and what we don't know about our software. So the goal of testing is rather, information than automation, I would say. And the reason for this is fairly simple. A test itself is just a question you ask your software. And the purpose of performing the test is to gain information about your software, to reveal those problems you've seen before. So testing always has been, and hopefully always will be, a search for information. And therefore, I like to see testing as an information service, not as an automation service. So in its shortest possible form, I would say that the purpose of testing is to collect quality-related information about our software to enable other people to make better informed decisions. That's it. So testing at its core is just about three things. It's about information, people, and decisions. So first, we collect quality-related information about our software. And that's information, for example, about the actual or the potential problems in our software. And then we provide this information to other people, people such as developers, people such as product owners, product managers, support engineers, release engineers, to enable these people to make better informed decisions based on the information we provide. And these decisions might be shipping decisions or fixing decisions, for example. So the bottom line is helping other people to make better informed decisions. So that's the key here. And that is how we create value through testing, from my perspective. Now, this then begs the question, well, how do we collect this information in the best possible way? Or in other words, what does it take to do excellent testing? And I want to give you an answer to this question by telling you a short story. And this story is about Alice. Now, Alice not only is a software tester, Alice is an excellent software tester. Now, excellent software testing is really hard to describe because you only find out what excellent testing is when you see it. So here is what I've seen. Here are 18 characteristics of Alice's testing excellence. Now, before I dive into these characteristics, I want you to do one thing. So I want you to just lean back now, to relax, and also feel free to close your eyes for the next 15 minutes or so, because I have to admit that the next slides aren't super exciting. The story is what truly matters now. So I will now turn this presentation into a kind of a play reading, so to say. And I really hope that works out. Now then, let's get started. Number one, Alice knows that testing is a social science. She knows that the quality of software is inherently subjective. So she knows that quality is valued to some people who matter at some time. And she understands that a bug is just something that threatens this value. So she realizes that a bug is simply something that bugs somebody, because she's learned that a bug isn't necessarily in the software, but rather represents a relationship between a person and the software. And therefore she accepts that quality cannot really be measured, but only assessed. So Alice acts like a sociologist who looks for different problems that matter to different people who matter, because she knows that different people will look at one and the same software as having different levels of quality. Alice also understands that our thinking errors can become software errors when we aren't aware of our cognitive biases. And therefore she looks for the bugs in the mind of people. So she acts like a psychologist, so to say, who dwells into the mind of people to analyze their thinking, because she knows that most of people's knowledge, including their opinions, their assumptions, and their expectations about the software, is in their heads. Alice is also aware that automated repetitive checking is important, because she knows that she cannot trust the software, simply because the software continuously changes its mind. The software and the business, as well as the technical domain in which the software is situated, constantly and rapidly evolve. Now, for that reason, she automates checks to make the process of comparing the current state with some past state of the software faster and less error prone. So she has also learned that there is no such thing as free lunch when it comes to automation, because she knows that automation requires maintenance. And therefore she treats automation like a cake, I would say, because she knows that a small amount of cake and therefore automation can taste great, but too much usually makes her sick. So she doesn't just automate checks. She automates checks that matter. She automates checks that repeatedly reveal useful information about the software. So the bottom line here is that Alice acts like a controller who carefully controls the benefit to cost ratio of automated checks to not get drowned in maintenance efforts. In addition to that, Alice clearly understands that software testing is not a mechanically one-dimensional activity, but a multidimensional, creative, and human-centric activity. And therefore, she sees human testers and their skills at the center of testing, not machines. Now, Alice is also a master in programming, I have to say, but she doesn't feel the need to artificially elevate her role by inventing new names for it. She knows that saying tester is enough, because she understands that she is actually being paid to test, not to code. And for that reason, Alice sees tools as something that can accelerate, that can extend and simplify testing. So she doesn't consider tools as something that eliminates the need for human thinking in testing. She knows that it is silly to blame gravity for falling flat on the face, and therefore she doesn't blame tools for the poor tests she performs. She knows that only poor testers blame tools for the poor tests they perform. So Alice acts like a leader who is leading by example, by holding herself responsible for her actions and accountable for the results of her testing actions. Now the list goes on, ladies and gentlemen. Alice knows that testing is context-driven. She's aware that there aren't any best test practices out there, only good testing practices in context, because she knows that the value of any practice depends on its context. For example, the project, the product, the people, and the environment. She knows that she wouldn't test an autopilot of an airline in the same way as a website. And of course, sometimes instead of finding and learning how to use a chisel, she sometimes turns to the hammer she's already holding. But in hindsight, she becomes aware of that. And therefore, she equips herself with a variety of testing techniques, such as heuristics. And she has these techniques ready in different forms, for example, in the form of checklists, in the form of cheat sheets, in the form of mind maps. Now, she does so to enable herself to design, to perform, to prioritize, and to analyze her tests in different contexts. So in short, Alice knows that testing is not just a talent, but rather a set of skills that can be learned. She also relates testing to other disciplines such as physics, mathematics, history, philosophy, and social science, for example. And she does that to broaden and strengthen her skills in problem solving, her skills in modeling, speaking, and her skills in critical and lateral thinking, for example. So Alice acts like a chameleon, so to say, that has the ability to adapt to new, unknown, or unfamiliar environments fast. Alice knows that the set of models she's using in testing are just a set of ideas about the software. So she's aware that these models aren't the software. These models are abstract representations of the software. And she's using these models to understand certain aspects of complex software in simple terms. She's using these models to form conjectures, to direct her testing, to make decisions, and to communicate her conclusions. Now, she's aware that these models are simplifications of the software, and she understands that simplicity doesn't precede complexity, but follows it. So she reflects on her conjectures, on her decisions and conclusions by considering alternative models, because she knows that these models are probably flawed representations of the software that are based on her flawed mental model of the software. So she acts like her own best critique, so to say, who questions her own models in testing to not get fooled by them over and over again. Now, Alice also acts like an astronomer. And the reason for this is simple. Alice knows that testing the software is more than just checking the specification of the software. So she doesn't just compare the actual software to its specification. She also compares the idea of the software to the actual software and to its specification. Now, she knows that the purpose of the software is to solve someone's problem. And therefore, she evaluates the purpose of the software too, because she knows that testing the purpose of the software is one purpose of software testing. Now, she does so because she understands that the conformance with the specification has little to no value if the software solves the wrong problem. So therefore, Alice acts like an astronomer who not only uses a microscope to evaluate the software from a rather small-scale technical perspective, but she also uses a telescope to judge the value of the software from a large-scale conceptual perspective. Alice also understands that those who cannot learn from history are doomed to repeat it. And therefore, she looks back to the mistakes she has made. She identifies patterns of failures, and she extracts the lessons she has learned. Now, in doing so, she neither denies her mistakes, nor she doesn't hide them. She documents these mistakes, and then she shares these mistakes with other people. People such as developers and product owners and her fellow testers, for example. And she does that by conducting regular retrospective sessions. And in doing so, she not only learns from the mistakes of other people, she also enables other people to benefit from the lessons she has learned. So she reflects on her mistakes because when she takes on new challenges such as new projects, for example, new releases or new sprints, to prepare herself to not repeat these mistakes over and over again, because she knows that prevention is just better than cure. So the bottom line here is that Alice acts like a historian. who builds a learning culture by analyzing her past testing activities to constantly improve her future testing activities. Now, on top of that, Alice also understands that having a testing specialist on the team doesn't mean to restrict the responsibility of testing to that single person. So she's aware that excellent testing is never done by one single person in isolation. She understands that excellent testing requires the collective brainpower of a group of people, because she understands that great testing teams are teams of diverse talents cooperating. In short, she knows that diversity makes testing powerful. So she knows that the idea of one person having all the answers is deeply flawed. So she understands that knowledge comes in many different flavors. And so she looks for, sources of potential support. And she does that through various different collaborative activities, which we call pair testing or mob testing, for example. So she acts like a guide who actively involves, guides, and advises other people in testing by stimulating these people to continuously think critically about the software they envision, design, and build. Alice also knows that the time needed for testing is always infinitely larger than the time available. So she prioritizes her testing activities because she knows that testing has to stop, although it actually never ends. She is aware of the fact that she cannot prove the software right, but only wrong. She knows that she has to think of falsification instead of verification. And she accepts the fact that she cannot answer the question, did we find all bugs? She understands that she cannot quantify the number of absent bugs because she knows that testing can only prove the presence of bugs, but not their absence. So Alice acts like a realist who clearly understands that software testing at its core is undecidable because she understands that the problem of finding all the bugs in the software is undecidable. In addition to that, Alice knows that testing is learning. So whenever she runs out of test ideas, she suspects that she probably hasn't learned enough about the software. And therefore, she keeps exploring, she keeps investigating and experimenting to constantly evaluate this conjecture. And she never stops learning about the software and the domain in which the software is situated. She knows that testing is experimental science. And so she sees testing as an adaptive investigation rather than a factory process of creating, automating, and executing test cases. So she knows that her test success is not defined by the number of her test cases. She knows that her test success is defined by the quality of her test ideas. So Alice acts like an experimentalist, so to say, who does not confuse testing with test cases, because she considers her tests as experiments to challenge hypotheses, to challenge assumptions, opinions, and various different perspectives about the software. Alice also acts like a stakeholder because she knows that testing means comparing the invisible to the ambiguous. She knows that the stakeholders' knowledge, goals, and experiences are not identical to hers. She knows that the universe of stakeholders is simply vast, but she doesn't get tired to examine risks for both internal and external stakeholders. She considers how internal stakeholders, such as product owners, developers, sales, and marketers, would look at the risks she is uncovering. And she ties these risks to their objectives, to their needs, and to their goals. She also examines risks from the perspective of external stakeholders, such as the customers and partners, for example. And in doing so, she avoids saying and even thinking things like no one would ever do that, because she knows the more advanced she gets in the software, the harder it becomes to relate to true beginners, to the end users. So she's trying to wear the end user's shoes, to not forget what it's like to be one. And therefore, she always tries to step out of her role as a software tester by taking on the perspective of different stakeholders, by looking at the risks from their vantage points. And she does so because she knows that these different viewpoints allow her to look at the value of the software and the impact of a threat against the software in a variety of ways. So she thinks like a stakeholder, so to say, to enrich the way she assesses, she prioritizes, and she analyzes risk to get a much broader picture of the overall risk profile. Now, besides that, Alice knows that she cannot expect answers to questions she didn't ask. She isn't afraid of looking stupid by asking simple questions. She understands that tests are questions. She asks the software to reveal useful information about the software because she understands that assumptions or unexamined beliefs are simply the termites in software testing. And she suspects that she probably has answers that might be wrong and beliefs that might not be true, but she isn't afraid of not knowing things. So she doesn't get tired of applying this crazy method called asking before she assumes something. And for that reason, she judges herself not only by the answers she gives, but also by the questions she asks. Because she knows that curiosity is what fuels excellent software testing. So Alice acts like a curious little kid who never stops asking because she knows that asking great questions is just the source of great testing. Now, Alice is also aware that if she doesn't have any questions about the risks in the software, then there is no reason to test at all. And if she has at least one such question, well, then she will ask, well, will these tests cost more to perform than the answers will be worth? So she acts like an accountant in a sense, because she understands that good testing involves balancing the need to mitigate risk against the risk of trying to gather too much information about the software. Now, Alice also acts like a skeptic because she knows that she shouldn't believe everything she hears and only half of what she sees. She knows that there are no facts, only interpretation. She knows that absurdity or that certainty is absurd. So she thinks critically about what she has been told about the software. And she's skeptical about what she knows about the software. And she knows that she will never know everything about the software. So she's aware of the fact that she isn't Laplace's demon, so to say. And therefore she focuses on what she doesn't know about the software. And she doesn't just settle with what she currently knows. So in short, she keeps thinking despite already knowing, because she sees testing as a thinking activity and she treats it like one. She knows that she has to change her thinking to change her testing, because she is aware that the software is a cunning deceiver that is always constantly trying to fool her in one way or another. And for that reason, she remains cautious, she remains curious, and she remains critical to not get fooled over and over again. So the bottom line is Alice acts like a cosmic skeptic because she knows that excellent testing is just the byproduct of continuous critical thinking. Now, Alice also understands that the primary goal of testing is to make other people aware of problems in the software. She knows that making people aware of problems is a socially difficult task because of the people's natural desire to avoid trouble. And she understands that problems are something negative at a glance. Now, she considers the problem as a deviation from what is perceived and what is desired. And the bigger this deviation, the bigger this gap, the bigger the problem. And the bigger the problem, the more it might threaten the value of the software. And she's also rational enough to know that different people will react differently and sometimes irrationally to potential threats. She knows that there are people, who welcome critical feedback and there are people who don't. She knows that there are people who value the perspective of others and there are people who don't. She knows that there are people who hold themselves responsible and accountable for their mistakes and there are people who don't. So what she does is very simple. She first of all realizes that the nature of humans is diverse. So she studies the people's personalities and their relationships among each other to make them aware of problems in a dispassionate, deliberate, and personal way. She understands that if she isn't making people aware of problems right away, then these problems will eventually find them. So she communicates this problem with modesty and empathy. She's direct, critical, but she's not judgmental. And therefore, she talks about negative things in a positive way because she sees problems as an opportunity to improve. She knows that the software doesn't have to behave the way she wants it to behave. She's aware that she doesn't design, code, or sell the software, right? She tries to help other people to understand the software they have got so that they can decide whether it's the software they want. So she acts like a friend who reduces people's ignorance about the software without embracing arrogance. Alice also understands that software testing is the headlights, quality is the journey, and the business outcomes are the destination. So she lights the way for other people by describing the status of the software in terms of what it does, how it works, and how it might not work. She describes her testing activity in terms of what has been tested, what has not been tested yet, and what probably won't be tested at all due to several constraints, such as time, resource, and budget constraints. She also describes the quality of testing in terms of the successes she achieved and the obstacles that impeded her testing. So she not only looks for problems that threaten the value of the software, she also looks for problems that threaten testing, because she understands that problems in the process of looking for problems, testing, can prevent her from finding problems in the software. So in short, she provides a 360-degree narrative on testing packed with useful and actionable information, instead of just bombarding her stakeholders with vanity metrics that are packed into shiny but meaningless dashboards. So she acts like a storyteller, so to say, who understands that testing requires doing testing and describing testing. And last, Alice also knows that she cannot assure quality in the same way a doctor cannot assure health. She understands that her primary objective, again, is to collect quality-related information to enable other people to make better informed decisions. So in short, she is aware that she tests, but others decide. So she sees testing as an information-based science, and she understands that she provides value through testing by helping other people to provide value. And therefore, she considers herself as an assistant that neither does quality assurance nor quality control, but rather quality assistance. Now, ladies and gentlemen, this list could go on and on and on. It's not complete, and it will never be. But I hope you get the point. Alice is a cocktail of testing excellence because her testing is fast, inexpensive, credible, and accountable. Now, if that was a little bit too fast for you, no worries. You can find all the details of what I've just said in my recent article on my LinkedIn profile. And this article is simply called Excellent Software Testing. And feel free to use this article as a basis, as an inspiration to work out your notion of testing excellence. Now, here's a little secret I want to tell you, and you might have already guessed it, right? The picture of Alice you're currently looking at shows my sister. And my sister has absolutely nothing to do with software testing. So what I want to say by that is that Alice is real, but only in a metaphorical sense. So Alice is a fictional character that symbolizes the collective testing excellence of a large, inspiring and diverse group of excellent software testers with whom I had the pleasure, the honor, and the privilege to work with in the last 10 years. Now, finally, let me highlight that this short story stands on the shoulders of these giants listed on that slide. So, ladies and gentlemen, don't follow me, follow these people, because they know the way, they go the way, and they show the way of excellent software testers. And that's it. That's all I wanted to share with you. So thank you again for joining. I hope you enjoyed the session. I'm now handing back to my friend Stefan to open the Q&A. Stefan, are you ready to kick it off?
Yes, I am ready, but the audience is not. Until now, no question. Oh yes, I have one question. Can you unshare your screen? Then the people have us in the full beauty of our faces.
Sure. Does it work now?
No, you need to unshare. Stop sharing. Oh yeah, now.
Here you go.
Ah. Yeah. You never change. Still young. Okay. There is one question from my right side. It's how often do you breathe, or do you actually breathe when you do presentations?
How often do I breathe? Do you mean practice?
No, breathe, like in oxygen.
That I breathe, okay. For the breathe in terms of short.
No.
I'm sorry that I went a little bit too fast. You know, it's my adrenaline that just takes on crazy levels. So I hope you will provide the recording, then you can slow it a little bit down.
Yeah, of course we will provide the recording. So
awesome.
Carlos says, I'm QA for over 10 years, so much I identify with the presentation. Thanks.
I'm glad to hear that. Thank you so much, Carlos.
Yeah, that's it's funny that I read this article from this Dutch agile guy. I do not remember him. The guy who wrote Management 2.0, Jürgen Appelo. And he wrote that he was at the presentation talking about agile, and there were some people, like 80%, who did not listen, but always wanted to know, and which tool, and it's like, it reminded me, like he said, agile is not about which tool you use, it's about your mindset. And it's the same with testing.
Absolutely. And Stefan, I think it's the same with every other discipline out there. It's the same with product management. It's the same with marketing. It's the same with C-level management. Jerry Weinberg once said, no matter how it looks at first, it's always a people's problem. It always comes down to people. It's always a human-centric activity. And especially when you have a look at, a little bit of the history of software development and software testing, and here I'm going back especially to, the late 50s. Jerry Weinberg was one of the first in the late 50s at IBM who had a dedicated testing team at IBM. It was the late 50s. And at the time, he described testing in terms of imagination, in terms of creativity, in terms of the drive to find problems, to figure out how things work, and not so much, how to make them work. And then the first book of testing came in I think the first one, 1972 or something like this, so almost a decade later. And then testing was completely redefined as something that is very mechanical, that requires tools. Automation is all we need. And it's like, the pendulum of software development and testing. And we've tried the same thing with software developers, right? In the 90s, with all these amazing tools that came up, complete marketing hype, we will completely remove the human activity out of software development, out of the coding, right? It never worked out. And I think in the same way, you cannot do that for testing.
That's true. There are two anonymous. I'm not sure if it's actually two people, but I guess so, because this cannot be that this anonymous person posts that many questions. So anonymous number one says, yes, it was a great presentation for me too. Very useful. Thank you. And was this anonymous number one or number two? Oh.
Now comes the but.
No, it's the other. Says, great energy. Thank you for sharing your love and passion to testing and QA.
Oh, thank you so much.
Yeah.
You just made my day. Thank you.
Look. These are the kind of people who would invite you for a beer, or?
I'm happy to join. You know, when it comes to beer, you know it, Stefan.
Yes, I know it.
I'll never say no when it comes to these kind of opportunities.
But now that we are here cozy in our not living rooms, well, maybe you are in your living room, I cannot see that. But you know, this view on testing, it always changes. Yeah, it's always like human centric, and now we are coming into an age where people simply wanna replace a lot of the anonymous for coffee. I don't drink beer.
Also fine.
Yeah, it's very good. Yeah, usually it's the same with me. He drinks beer, I drink coffee. So that's
Well, not in the morning. I mean,
in the morning. No. So where was I? Oh my God, this completely wrecked my train of thinking.
you again tried to talk about how testing has been influenced, especially in the last 15, 20 years by Agile, DevOps.
And I was preaching into this, just like the people said, let's automate everything. Now there is this one swing of the pendulum. Let's AI everything. And today there was the great talk by Evelyn about from Synflower, the company who do AI-based unit testing. So, which is a nice thing. Yeah, there is nothing I wish more for software developers and testers than to know that this piece of software does not only do garbage collection, it also does unit testing on its own.
Yeah, I mean, there's so many aspects to unpack here, and I think we won't have the time in the remaining 2 minutes. So for all the software testers joining this call, I also have an article on my LinkedIn profile where I tackled especially this question. The reason is simple. We need to be prepared to have an answer to this question, especially, when management comes along and says, we automate everything you do, which is an awful understanding of testing. So have a look at the article. It's called, Will a Bot Steal My Spot in Software Testing? Will a bot steal my spot in software testing? And a very simple exercise everyone can do, also outside of software testing, is to answer this question is just make a list of activities you perform when you perform testing. Just make a list. And for each item on that list, I've shown that in my article, decide whether this can already be done by a machine or not, or whether this can be done in the next at least 2 to 4 years, right? So this is the way I usually prepare when I'm confronted with that question. And when you do that exercise, it turns out quite quickly that there is no hope that a machine can do it, at least in the near future. I don't know what will happen in the far future. If we will really reach the singularity, right? If we reach the AI takeover, I don't know it. But for now, I can say we still have a safe place as humans. And never forget, when we talk about Agile and DevOps and how it changed testing, I always try to remind myself that testing is testing. Agile and DevOps is context in which testing is being done. Yeah. So that means all these new processes, even though they are just a set of values, as you've pointed out correctly, Stefan, that do not change the fundamentals of our discipline in the same way they do not fundamentally change the way I develop software, but just change the process around it. That's the way I would like to see it. So to separate context from the actual activity you perform.
Yeah, I have one question. By the way, Milan will contact you on LinkedIn. Beer or more. Okay. And Anonymous has a question. He wants to know, what are the testing tasks that should be better performed by devs instead of testers? I see higher quality in software when developers feel responsible.
Yeah, I mean, I've tried to point it out that to me, testing is kind of a team sport, right? It's like testing, I always try to say testing is everyone's responsibility, you know, and then I get the complaints. No, we have the testing specialists. Here I like to distinguish between responsibility and focus. Okay, I still say it's everyone's responsibility because, you know, testing doesn't stop in software development. It also goes beyond that.
Yeah.
But still you need to have someone who has the focus on testing, and that is where a dedicated testing specialist comes into the team, and that is the one who then guides and advises other people. For example, what we already did, or what we constantly do in our projects, is we pair testers and developers when, you know, things are being developed. The same way you do pair programming, you can do pair testing at every single stage. I've been a product manager all my life, and I've always included software testers in the very early stages when I have half-baked ideas of how the product should look like, because these guys are skilled. These guys are skilled in critical thinking, and they can help me to reveal gaps in my thinking. And from that perspective is try to include these testing specialists whenever you can, because it's all about critical thinking. And, you know, I hope that testing specialists on your team do have these abilities. I hope that somehow answers the question.
Yeah, I think it does. Okay, so last questions. Do we have any more questions? No, we do not have any more questions. That's good, because that means that we can say thank you, Ingo, for your talk and for also giving us energy, inspiration. Yeah, like always.
Yeah, thank you so much, Stefan, and the rest to the organization team for having me, and to the rest of the audience. Enjoy the rest of the weekend. Feel free to get in touch with me. Ping me on LinkedIn. That's, I think, the best place to get in touch with me. Thank you so much.
Okay, thank you. Bye bye, Ingo. I think, yeah, since this is the last, you can say goodbye to everybody. Ingo, do not run. Ingo, do not run. Milan says clap, clap, clap. Oh, cool. Tomorrow we will be back at 10 in the morning. That's bad, or that's early. Yeah, okay. So we will be back at 10 in the morning for another workshop. So, and this time it's really a workshop. It's no startup pitching. I'm not mixing stuff up. It's really a workshop. So just have a look at our nice, beautiful program, our agenda. And other than that, never forget, testers do not put the bugs in the software. They are already there. And developers didn't put them there either. So, yeah, like Ingo would say in this moment, it's time for the bug busters who come in and get out the bugs, and it's a team sport. This being said, have a nice evening. Enjoy, or if you got up now, have a nice day, and yeah, sorry it's already late here. So, and this being said, do I need to say anything more, Gary? Okay. Vessi, do I need to say? No. Thank you, and bye bye. See you tomorrow, and bye bye, Ingo.